Find a 10-digit number, but the first digit is how many zeros? How many zeros? So it's a guess and check, you know. Just enter the number that you write down. Fits all the criteria. It's an incoming call. Zana, can you see the introductory activity?
Hi, yes, I saw it.
think I don't know right. Something's wrong with this. Until the 10 digits. Sorry. Oh, I'm so sorry. I made an error in the recording this. Until the 10th digit is how many nines in the number. Sorry. Made an error. I'm going to need this. It's like January. Yeah. You had it. Yeah. Transfer.
Answer to number one, you have reference with one.
Take a file at the 10th digit. Find a 10-digit number with the first digit only 0. Yes. The second is the only ones.
The answer.
Yes. And in the number, etc. So what you get a pattern there. So if the 6, so look at the pattern. The 10 digits, the first is only 0. The second is only 1. And the third is going to be 1. The third is going to be 1.
Oh, it was more.
Right. They are good business. Very, very good. There's another pattern. Very, very good. I see how good base here. So think about it. Very good base. You have the digits. You have the digits, and it's like 1 digit, so you need to think it a little bit more. Read again. The first represent what? All right. So look how you just started. Look at what you get. Okay. No. How many, the first represent is the first they have is 2. You represent how many zeros? How many zeros they have? They have all the values except 1. All the values.
How many zeros? It's remaining 5 digits. And it's a final. Here the first is only zeros in the end. Now, if you have a number, pretend the number.
How many zeros they have in the corner?
Absolutely.
Mm-hmm.
This is not a result of first.
All right. So here's the one thing. Read again and come on.
That's not true.
Anya, are you finished?
I think so. I'm just double checking.
Okay, Zana, are you finished?
No, I'm not finished.
All right, Jeffrey, are you finished?
Yes, I am.
All right.
But I'm double checking.
All right, give us some more time. Did they come to it? I don't know about it. Carlene? Welcome, Carlene. Carlene, are you hearing me? Your mic is off, Carlene.
Okay, I'm hearing you.
Okay.
Good day.
Good day. Introductory activity here on the board. Can you try to do it for me, please?
Okay, let me see.
You are on the right hand. You need to take out one something. Ah, yeah. Read the first instruction. Read the first instruction again. I know, but look at the first thing. What does the first thing say? How about insert the numbers? What do you have no? No. That's not right. That's not right. First thing is close, whatever. All right. I think I'm ready to go. Let's see the answers that you're coming up with. Who wants to go first?
I can try.
All right, go Zana.
That's Anya.
Huh? Anya?
That's Anya.
Okay, go Anya, sorry.
Okay, so I have 6, 2, 1, 0, 0, 0, 1, and 3 zeros.
Okay. Any other? Any other? What did you get?
Same with Anya.
Same as Anya. Caroline, are you there? All right, Anya, do you want to take us through the process? How you came up with the answer? Or who wants to do it, Jeffrey, since your answer is the same?
Okay, well, I'll tell you what I did. What I did, I figured I wouldn't be using the last digits, the 8s, 7, 8s, and 9s, because we don't have enough space to have so many digits. So I just filled them up with zeros, and then I left the first digit for last.
Okay.
Because I figured I'll have the most zeros. So at first I had zeros up till the middle digit, which is the 5th digit.
Mm-hmm.
And then I just kind of play with the 1s and the zeros before that, and then I ended up with this number. And then I put 6 last because I ended up with 6 zeros.
Very good. Good job. Any other method?
Well, I did it similar, but I just started.
Welcome, Sabina. I didn't know that you were there. Welcome.
Oh, I'm there. I started with elimination. I started with the first number 9 and the 8 zeros, and I eliminated and reduced the first digit as I went along until I got that number.
Very good. Good job. Any other method? Jeffrey, how did you come up with your answer?
I just played with the figures just like Anya was saying.
Okay. All right. Where is Zana? Is Zana there? And I'm not seeing Caroline either. All right. Now that we have passed the introductory activity, I just want to welcome you to this summer 2 semester. I hope that it will be a productive semester. Now, I just want to address a few things from last semester, from last summer, or summer 1, let me put it like that. In terms of the assignment, I'm going to give you a little bit of, I'm still not finished marking. And all the marking, all the assignments will be second marked. But I must tell you so far that what I noticed is that some persons did very, very well, very, very well. But what I noticed is that we're not answering the question. So for example, when I say, tell me what is your understanding of differentiated learning, and you use relevant examples, it will suggest that I don't want you to tell me what Bruno says about differentiated learning or anybody else. I want your understanding. So that might mean that you would have to go and do what? Read and then determine what you understand from it, right? And write that in your own words. And then if I say use relevant example, that would suggest that I'm grading you for an example, okay? So, and in terms, so the point I'm making is that please read the questions properly and answer only what is asked of you. So for example, in the essay, I don't remember this thing what the first assignment was. If let's say I ask you to list three reasons why you need to self-analyze as a teacher. And if you're going to tell me things like, all right, okay, probably you can give me the definition for the first reflective practice or what it means to self-analyze. But don't tell me things that I don't ask you for. Really, what I needed, if I was to ask for 3 things, I need 5 paragraphs, 5 fully developed paragraphs. I need 1 introductory paragraph, just giving out the overview of what you're talking about. Just 3 paragraphs and talking about it, 3 things and a conclusion. Don't tell me other things that I don't ask you for, all right? Because if you tell me things that I don't ask you for, but the things that I do ask you for, you didn't put in your essay, that is going to give you a very low grade. Are we clear?
Clear.
Yes. So please pay attention to that. That was the main thing that I realized that we weren't answering what was asked of us, okay? All right. Now for this course, we really want to focus on the CSEC report. So I'm going to bring it up and we're going to look at it a little bit. I want you to read and just write down anything that comes to mind. Then we're going to go through it and look at how we can correct some of the misconceptions and errors and some of the complaints that the reporters wrote on the CSEC report, okay? I just want to bring up my thing. Okay.
That's what I see.
I'm probably going to use maximize because some of the ones that will come. But I mean, you be able to see it. So if I want you to be able to see it, I do.
No, it's okay. You'll see it first.
Which year is this year?
January 2014.
No. So you have an idea of what they're seeing when you look at this? So what they are seeing?
All right. So what I have here is a Caribbean Examination Council report on candidates' work. So this is a CSEC, January CSEC math paper, okay? We're going to look at the paper, and I mean, I'm thinking that this paper should inform how we really teach. The grades 10 and 11. Even though you have some things that they'll be learning from basically primary school, but we're going to look at it to see how it will inform our teaching. Thank you. No, it's not going down. All right. Yeah. So the first thing we're going to look at the multiple. So we have, this is the multiple choice section, but the main thing we want to focus on right now is the structured part of the paper. Alright. So can you read this for me, please? Just read it to yourself, and if anything hits at you, just write it down for memory, because we're going through it. Can you see?
Yes, we can see.
Okay. Alright. I don't understand this. I'm gonna take my time, bro. I don't like this. Because I just want to go down with it.
Actually, something else needs to see. Actually, something else needs to see.
Alright. The difference between the both for her teach topics and stuff. Good afternoon. Alright. So the first, good afternoon, Ingrid, welcome. And the first one we're going to look at is the compound question, question 1. This is what candidates are supposed to be able to do. First thing, they're supposed to perform the 4 basic operations and common fractions. Now, this is what I want you to do. I want you to first write down all the possible misconceptions you've observed over the years from experience in doing the 4 basic operations and fractions, all the possible misconceptions and all the errors that you've observed. Then we're going to talk about them and how we address them. How do we teach so that we don't have our students making some of the errors that you've noticed? Then we look at what the CSEC report is saying about the errors that students usually make. Are we clear? We're going to write down all the errors that we usually observe when students are answering this part and all the misconceptions. It's on the second, it's at the ground floor and the first floor. I'm going to say that. You know, school of education. Just go there, go to the reception center so you can see what's in it. Oh, yeah, that's how it's covered in the whole. Is that not multiplication? Is that not multiplication? Is that four? It's too big. So we're going to go through this one. And then we'll finish this. We're going to start. Do this. I'll turn the arrows. And so, another one else? First part. I'm going to look at how we address the errors. Because I'm just focusing on the paper. That's the one. January 2014. I'm finished working. Alright.
Yes.
But alright, also do some of the common errors. Remember that we know that there are difference between errors and misconceptions, right? What are the difference? And what is the difference? What is the difference between errors and misconceptions?
Error is not the consistent thing.
A misconception is when there's a certain way to do something, but you understand it in a different way from the set way. That's a misconception. And an error would be if you work in something and for some reason you, maybe because of time or something, you made like a silly mistake. What you were supposed to add, but you subtract, something like that.
Okay. Anybody else? Not bad.
Yeah, the same sentiments. I think what I think a misconception is, okay, well, in terms of the algorithms to solving fractions, that can be a misconception. There are certain steps that you have to take, especially when it comes to dividing, multiplying fractions. When you have to change dividing two fractions, and you have to change the second fraction to the reciprocal. And an error can be, okay, let's say, for example, I'm adding two fractions, and instead of saying 7 plus 4 is 11, I'm saying 7 plus 4 is 10. Something of that nature.
Okay, anybody else? Any other of you? Good try, Zana.
For error, I don't should be more like consistent, because mistake is a one-off thing, but error is more consistent. You keep on giving
misconception, you know?
Yeah, misconception
and errors.
So error is consistent, mistake, as you said, and misconception is like you learn a concept and you try to apply it and it does well. As for the multiplication of fraction, the concept of multiplication that is that we multiply things get bigger. But 8 times a half is not necessarily, the result is bigger than 8. So you get 4 and 4 is not bigger than 8. So this conception you get trying to learn that multiplication increases things, but it's not really applied across the board. So basically that's what we understand. Once it can't be applied across the board in a sense, it's more like
you're saying the right thing, but good try. Ingrid?
I think a misconception is when you have the wrong idea about how the concept works.
What's the error? I said yes, that's what I can agree with. The misconception is a wrong idea. Wrong idea. So, for example, if the concept is called a misconception, what's the concept? You know, so you have a wrong idea about this concept. So, for example, my as you were explaining, my idea, let's say the concept of multiplication is repeated addition, but I don't see that concept. I have another idea in my head. So that is a misconception, a wrong idea about let me just put that the wrong idea. And the error is, most time we have careless errors. For example, most time it is in algorithms. So if I'm multiplying 5 times 4 and I will get another answer instead of the right thing, those are errors, and some of the errors are careless errors. But misconception is just a wrong idea, and they're two distinct things, two different things, okay? All right, so we're going to move into now, what are the misconceptions you came up with? What are the misconceptions? Should I start with you then? Mona?
The first one I have for addition is we're adding 2 fractions. I think they should just add the numerators and then.
All right, so if I have, let's say, half plus a quarter, they add
1 plus 1.
And this gives 6. All right, that's 1. This is a common one that I've seen so many times. Agree? All right, anybody
Agree.
Else? Zana?
Multiplying fractions, well, dividing. A half divided by 4/2.
All right, so let's look at the addition and subtraction.
Okay, all right.
And then, yes, then we go to subtraction and addition. So this is an error, the wrong idea of how fraction, the concept of fraction. You get the difference now, it's the wrong idea. Yes. Who wants to go?
Some students, they just find the lowest common denominator and they just add the numerators. So if you have a half and a third, they would just put 2/6 for you.
Okay. Yes. Any other misconception with adding or, well, I guess addition and subtraction would be basically the same, somewhat similar. Yes.
I don't know if this one would be a misconception with subtraction, but sometimes that's what to work with the whole numbers first, and then the fraction of first. And
so,
then
for example, if you have 2, I know what you're saying. If you have 2 and a quarter, and the next day was 1 1/2.
Yeah. So they subtract.
They say have 1.
And then they add the other 2.
And then, yes, this is definitely a misconception. Let me tell you what the problem is. After they subtract, they leave the whole number. Now they're supposed to take out from this 1 1/4. They're supposed to take out the 1/2. So what they do now is put the 1 here, so and they try to take away the quarter. This and end up with a negative. I've seen this before. It's a big one. So they put the 1 here. And they find the LCM and try to subtract. So they subtract here, put the 1 here, they find the LCM here, and then they try to subtract as usual. Have you ever seen this one before?
They add them because they didn't have the minus sign.
Oh, because they have, okay, I see. I've never seen that other one.
I've seen that.
Okay. Any other one we can think of? All right, the question is this. What do you think caused these misconceptions? Think about it for 2 minutes. What do you think are the underlying causes of this misconception? Or for these? What do you think? What do you think? Yes, sir? Who wants to go?
The student probably didn't really understand the concept of fractions to begin with. So when we ask them to conduct operations using fractions, then they would have problems because they didn't really understand what a fraction was in the first place.
Okay. Any other? Good. Any other person?
Yes, they are Dominica. Abstract algorithms.
Abstract. I love that word. Very good word. Abstract algorithms. Yes. Yes, Diane. Welcome, Diane. I didn't realize you were there.
Well, I'm here. A little sick, but I'm here.
Oh, sorry.
Abstract algorithms. That's when there is not a foundation where like you play and they like how we had our tiles and they understood the size and what it is about, and you just jump into, okay, let's find the LCM and whatever. So if you miss anything inside it, you might be reaching fifth form, you just still never got fractions because the beginning wasn't there wasn't enough understanding then before they apply the algorithm.
Well said. Very good. Anybody else? That's the thing. Abstract algorithm. That is just algorithm. So the point is the student probably don't remember when to add across. Is it that, you know, they don't, because when they don't understand, then they have to rely on what? Memory to remember what to do. That's the issue. Just stand on the board and demonstrate the procedure, that's a major issue. And that is the reason why students are making so many errors. All right, what I want you to do, looking at these errors that you have highlighted, I now want you to plan, think of an activity. I want a visual representation of these 2 activities I want. One, yes, so a visual representation, it can be, remember you're supposed to have your math kit. I'm going to send you later what I should go in your math kit. But pull out your math kit, okay? I want you to visually show us how you'd address this error. And I also want you to come with a real life scenario and to how you would help to address these errors if you notice them in the classroom. How would you go about addressing these errors? So I want something that is something can be a diagram or manipulative, but something visual. And I also want you to come up with a real life example. How can you connect this to real life? Are we clear? Are we clear?
Yeah.
Yes? Zana, are you clear?
Yes, sweet.
I'm clear. I'm clear.
How many of them do you want us to do it for? Number one,
Okay, generally, if you came up with something that can address all of these errors, because basically, you know, the main thing is that it's a mistake. The students
okay.
are not, they just learn procedure. So one visual representation, diagrams are manipulative, and one real life example. How do you apply this fraction? Show them that fraction is in their everyday life, okay? That's really true, sir. So I want to the
I don't know if you have
because there are 15 to the other place. Oh, the first order, everything now. Can't put all over the place. Because the person doesn't know that they can't get all over the place. We're not working right now. Why does it go to work together? I know what it's for. Oh, yeah, it's for that side. This goes to the back. Yeah, exams. I'm setting more practical. I'm still doing it. I'm the other person around. Did it feel the last time? What, anything? Education, English education. I can get lots of friends with certain. Oh, it's the new I know. Sharing cake and chocolate. Okay. How much are you going to do? You don't tell me how you use it. I'm going to explain. Hmm? Action box. I saw the first on the phone. I wanted to what they were calling, but I didn't really understand. Oh, that's what they're calling. Action box. But I think, since the difference, they have to, they can compare. They use that two fours, same as a half, they compare it. That's your idea. Yes, for the paragraph line. More recommended bars. But no one saying here is abstract. I know what we can raise the yeah. But for the beginners, you know, for them are we finished? Or need some more time?
Finished.
All right. So I wonder if anybody thought about number using number line or anything like that. No? Come on, think about it. Think about it. Give it 2 more minutes to add a fraction. I can't use a number line. You're not supposed to. Okay. You did it last term, maybe? Yes, you did. This is just warm up, you know, because we did fraction last semester. We haven't touched circle theorem and linear programming yet. This is warm up because we did fraction. Really warm up. right? Can't give it any more time. All right. Mona's still working, so I'm going to allow somebody else to go. Jeffrey, you're finished for a very long time, so you can go. Sabina, are you finished? Diane? Tasha is not here?
We haven't seen Tasha. I was thinking of using in my math kits, the fraction pieces that I had, and I would show them how to, like with the quarters, I would tell the students, okay, let's take away a half. We have the quarter one, so let's take away half of that and let's see what we have left. Or let's take away 3/4, let's see what we have left. Or let's add a quarter, let's see what we have now. And that's what I was thinking in terms of visual representation. And in terms of real life situation, I would say to the students, at your birthday party, your mom gave you a birthday cake, which you are supposed to share equally with your 15 friends and yourself. What fraction of the cake did each person receive? So the students would have to figure out into how many pieces they would have to cut that one cake first, and then try to figure out what fraction of that, when you cut it, what fraction of that whole cake did each person get.
And so I'm not seeing the addition or the subtraction. Neither addition or
okay, well, the cake, the first thing they would have to do is cut the cake into 16 equal pieces. And then afterwards, if you have to check what fraction you got yourself, you said we were supposed to do it in terms of fractions in general. So I was just using fractions in general.
Okay, I thought, well.
So
sorry.
So I was saying the student will have to look at what fraction of the cake after you cut it into the 16 pieces. How much did he or she receive? If he got 1 piece, then that's 1 out of 16 pieces.
Okay, I get you. Good. Diane, do you want to share? Or should I go to Sabina? Diane, do you want to go?
The first one, I found the pieces okay, but a fraction wall might be more visual to some people.
A fraction
wall? The wall chart where you have the 1, and then you have the halves.
Yes. That's a good one. That's a very good one. Very, very good one.
Yeah, so they can actually see that when it comes to the quarters, you take 2 of them to make a half.
Very good. Very good.
With fractions. Yeah. I don't know. That's my idea. I think it might be easier to see than the pieces.
Yes, I think it's easy. I agree with you. Having that fraction wall there, it's just that you can make anything. There's something you can make, or long fraction strip or something that you make where it would look something like a fraction number line, depending on what you want on it. You can start with quarters, halves, thirds, whatever you want to start on it. So, and you have it up. The students can literally see it. And you can even have them moving on it, like, So where are you, And what it's going to say, they can literally do the addition on it. Good. Very good, Diane. What about your real life application? Real life example. Diane, are you still there? Nice. I'm not hearing Diane. I guess our internet is out. Sabina, are you there?
Yeah, I'm there.
Do you want to go?
I don't have a real life example. I'm still thinking about it, but I would use the fraction pieces.
All right. Zana?
Yes, I'm there.
All right. Do you want
for the explaining, I'm not sure if the number line would work. But I think what I would have done first is to get students to see that what fractions really are, in terms of basically it's just The term we used, in last class. Just keep forgetting it. But nonetheless, this is saying that it must be one whole that you're taking and breaking it down into pieces. And then if maybe we could get them to see that that's what fractions really are about. And then with what Diane explained, I actually like that idea because actually they will see it themselves. And then what I would do is ensure that I would allow them to, you see, just as we were doing. To me, I find that very interesting, getting them to get their own way. I don't want to teach them that 1/2 + 1/4, you find the lowest common denominator. Get them to manipulate it themselves. Get them to find their way through it so that at least they will have an understanding of the concept as opposed to me just giving them an algorithm according to what it's saying. Just me giving them a step-by-step. Give the understanding, then there will be no need to memorize the steps.
Very good.
That's what I would do. On a real life, I have is I give you, for example, we have 10, maybe 20 sweets. Jane gets a half. Peter gets 3/4, not 3/4, or 1/6, and maybe Tom gets 1/10 of the sweets. You get the remainder. How many sweets or what fraction of the sweets would you get for yourself? So at least they will get to add and subtract from the whole.
All right, good. And I like that example. Why? Because I don't want them to see, I don't want them to see that all there as just, the one. Because when you have 20 sweets, whatever you have there, that's the whole. Those 20 sweets, that's the whole. That's what they're working with. That's a very good example. That's the set concept of fraction. All right? Good? Anya, are you there? Do you want to share? You guys are next.
Yes, I'm here.
So to excuse like you want to share with us.
Oh, well, is the fraction piece that I would have used anyway. And the real life example, I would have probably did something with like a recipe, like your mother sends you to the shop to buy milk and she has to bake a cake, she has to make bread. If the cake uses 2/3 of a liter and, something like that, and then just ask them to add it up so they can determine how much milk they need to buy from the store or if there is enough milk in the kitchen or something like that.
All right, good. I say you guys don't.
Well, it's basically what I would have here is basically similar. So I was thinking that we've used the beans box and the shade.
Yeah, that's a good idea. That's
to add. And it could also shade to subtract.
Yeah, X and
right.
Cross out.
Right, that's for the addition and subtraction. And my thing was a pizza, because I know kids love to go after school, especially weekends.
Good.
Like pizza. So they have one pizza and so on, and they have to share it. One person wants a quarter, and the next one wants a third. How much is left for the other person?
Good. The idea is this. Whatever I keep asking you to connect this to an everyday example is that students, we tend to remember things that we can relate to, right? The things that we can't relate to, it's not, we don't remember it, and we can't understand it. So we have to remember that they need a prerequisite, that we have to build on that prerequisite. So when we provide that connection, that linkage, we can link it to real life, then it makes a whole utility then, even if the subject becomes relevant, like they can see how they can utilize the math that they do in the class every day. Mm-hmm. And the fact is they have something that they can relate it to. So it makes better sense for them, okay? All right, so we're gonna move on quickly to the next two operations, that's subtraction and division. Oh, sorry. Multiplication and division. Yes. All right, so you're gonna come up with look here, there's so many errors that I've seen when students multiply and divide fractions. So what you're going to do, you're going to write down all the errors and all the misconceptions that you've observed over the years. All the errors, and I've seen, like the addition and subtraction, not so bad, but the multiplication and division, it is abused, like really abused. So we're going to write down all the misconceptions. Huh? Really? I'm going to divide in the dividend and invert that instead. Like there's so many things that, like, and then, yes, and still the simple LCA one.
I know that one, that's another one.
Anything add to that, everything.
The concept of division. definition generally. Sometimes they don't know what is a divisor. 4 divided by 5, they're not sure which one should be.
And that is something that we have to pay attention to. We have to tell them, this is the device. Why is it the device?
But one of the questions, when you go to the report, architect, why this person doesn't teach us what to do?
Yes, but
don't tell us like this. I mean, teacher but the problem is that
maybe that's the problem we're telling them. But look, I'm going to show you the stats.
No, that's not the problem.
When you look at the stats, look here, so look at the stats and see like how many students answer 10 marks, for example. It's only 2% getting like 5 out of the 10. Then you start to realize something. I'm going to show you something. Something is just wrong. That's when I started to I don't memorize stuff.
No, but
I just remember that.
That's what we say now. I think teachers tell them about one thing in third is that whole mathematical understanding the mathematics. It's not there. They need to know what yes. Not to tell you this about
telling.
No, it's not. This is the problem now.
No, what I'm saying
is that the assessment, because when you look at the countries that are doing well in PISA, Singapore, Finland, those countries, you know how they learn that? Very tough time. But they do the same exam, they do written exams too.
But I mean, for also,
you know, that's what our teacher quality is. Like, I know that there are many factors. The teacher quality is the main. I think you want to do that. It's just tell us how to get the answer. Because of the culture. This are you going to text us on how I'm ready? Yeah, at the time they will get used to the this are you going to test us on your yes. But sometimes we have to change the way we assess too. That's another thing. We probably need to change the way we assess. Instead of the assessing them, find the answer of the value of blah blah blah. We have to explain so and so and so. But you know, we have to change the way we assess. Show how we will solve this. We have to change the way we assess. I was saying, whatever that
they will answer the next question. Even faster stuff.
But it's more than that's why when they go to college they struggle so much when they have to learn. But that's honestly that's what they have. They don't want to ask me for everything. I know that they're I don't know. Because even the college work is but I felt like the people is teaching. You know what I don't really think that you have something like the one that we have like grandma and people teaching about the parents come and sit down. Instead, you guys
I mean, this was in the when we say the parents only was in 90. I think they just showed up online.
And they come and sit down in the class and observe. Even the teachers have to know the person. And so the teachers have the whole body and the person. Like the students, look at the person primary. They go to the first school. So what is the parents? But look at me, my age was very long. I'm sorry, and she would go with us. They can raise it. Imagine the report when she did your report. That's what we have to know. We can't ignore it.
It's alright. No, I'm saying it's alright.
Alright, are we finished? Alright, did I start? So I'm starting with, did I start with you earlier? Mona? Alright, so I didn't start with Mona. So
I gave you the first one.
You gave me the first one? Okay. Alright, so I'm starting online. Who wants to go first?
I can go.
Okay, go.
Sometimes the students, if you give them a half divided by 1/3, they would change the sign to multiplication, the division sign, and then they would just work it as normal. 1 times 1 is 1 and 2 times 3. I have another example as well. Do you want me to give it to you? Sometimes they would input the first fraction. So if it's a half divided by 1/3, they would put 2 over 1, yes, times 1/3. And you get 2 on 3.
Yes. Anything else?
I have others as well, but let somebody else try.
All right. Who else wants to go? Nobody else? Go. Yes.
For multiplication, I've seen them where they're using the LCM. The proceeding as
that is the common one I've seen.
They proceed as well.
They multiply this and they have an LCM and they have 6. And I don't remember where they go from here.
They do like addition.
Because I know, yes. So they 2 into this, 3, and then put the multiplication sign. I've seen this one. It's the common one. That's a common one.
I've seen this one, so I actually had it.
Yeah. Yes, you see. Anybody else want to add anything? Anybody wants to add anything?
I have another example.
Yes, that's Anya.
Yes.
Yeah.
If you have 1/6 times 1/3, what they do, they say 3 into 6, 2, like they cross it out. So they say 3, 3, 1, and 3 into 6, 2, and then they multiply.
This one and equal a half, 1/2. I've seen this one because they applying that canceling concept. So then they apply that here. So that's this one is a common one. Very good. So it's a very common one. Yeah, I've seen that. Yes.
Miss McArthy, there's a common error that I realized the Form 3 students when I'm teaching them fractions. They usually, that's grade 9, sorry. They usually, if you give them 1 and 1/2 times 1 and 1/2, they add the wholes and they multiply the fractions. So they would give you 2 and a quarter.
Yes, that's true. And I've seen this also where if they're multiplying this, they 1 times 1 is 1, and then they multiply across and get 1 and 1/4. I've seen that one also. No. Let's look at it. I guess we might know we can start to deduce what the underlying causes are, or what the underlying cause is, right? And what is that? They only learn algorithm. Yes, they only learn algorithm. And they get confused. They don't remember, there's no concept. They don't have an idea of what is happening. They don't have any conceptual understanding. So then they get confused in terms of, is it when I'm adding that I do this, or is it when I'm multiplying? Is that, yes, and I remember parts of it. Yes, when I'm dividing, I'm supposed to flip something, but what is it that I flip again? Oh, I'm going to flip this one. So, are we getting the idea? So, this is it. How do we address these issues? So you're gonna write now. Activities for addressing. I'm just gonna ask you to write one activity for what if you write? Excuse me. Activities for addressing these issues. So I want, yeah. So 2 activities for addressing these issues. There can be one, something visual. One something visual and one for something visual and one for one real life example. Okay?
Just look at the what's in there. I'm not a foodie. You show me too much food. That's the map for me.
Oh, I was going to say that's part of my girl.
I really love yours.
We have different,
Just like over the other. Yeah, one
about this. Yeah, I think this is one of the best models I've seen.
1 times this, 1 times 1.
Huh? You've never used it, never done this? Yeah, man.
It's really a square. Or a rectangle.
This is what they call the error model. Then you finish your add up everything. Yes. Yes, so you've never seen it like that? So they know how to add properly. There's another method they could use. Anything times 1 is 1. Anything times it's like, so that's going to give me a half. This is 1. A half times a half. A quarter. And this is 1. This is 1. So let's store a quarter. Quickly.
I would keep my voice that way.
Take us on him.
Not saying the other one is good.
What's the other model?
It's just like how we're using addition money when we drag back and stuff. It's the other money. We got like 2 fraction of 2 box, or you divide it. And then I don't remember.
Oh, is that is not for them? That's for the multiplication. That's for the multiplication.
You already want to make and get the same result. I don't Connection, application connection. So,
let me see if I can find what to say.
Show you a very good example of how it should be. Alright, what are we using that? Color, the device option, and the color.
And shade.
And shade, so
And multiplication.
like they use a blue one and
That's multiplication.
a blue one there.
And I don't think I showed you that the last one.
They show
That is my multiplication. I don't think that's a fraction.
Exactly.
Because remember, they have to learn addition first. This is easy for them to add. It's very easy for them to add. Yeah, right, exactly. Multiplication is really a rectangle.
So it's an error.
Yeah. That's why they call it the error model. Are we finished working? Need some more time? All right, so you Mona students going first? Yeah, they started first, so you guys are going first. I just showed you the error model. That's what we're doing. That's what you're doing, all right. All right. So, who wants to go first? Zana, are you ready? No?
Not really, yeah?
Not ready?
No, not yet.
All right, not yet. I'll give you 2 more minutes. Jeffa, ready? Anya?
I can try.
Which one are you trying?
If multiplication.
The multiplication, okay.
If I'm going to give you my own example. If I want to show my students how to multiply 6 times a quarter, are you hearing me? It's raining heavily in the background.
6 times a quarter.
And I can use these blocks, have them, instead of, I'll have them shade probably on one of the flat ones. I'll have them shade, let's say we'll take 6 of them to represent 6 holes. However, I'll have them shade off 6 of the little squares so that I can show them that we're dividing 6 into quarters, 6 holes into quarters. And then I'm going to tell them, let's find a quarter of each of these unshaded parts. So then they would be left with 4 little parts, so they have to find a quarter of each one. And then they would realize that they had 6 areas shaded in total. So it's 6 out of 4. Is it a bit too difficult for them?
No.
Or if you draw it, can you draw? If you draw it to show them, maybe those from Mona. Can you draw?
Draw.
Like.
Well, I'm gonna tell you. So we're gonna have our 6.
Draw 6 rectangles of the same size on the board.
As much as you can.
And divide them in 4.
So she's doing 6 quarters. That's what she's doing. She's doing, yeah.
Divide. You're missing 2.
Quarters.
Divide in 4. Yes, in quarters.
She's doing 6 quarters. What does 6 quarters mean?
Interesting.
If you shade 1/4 of each of these 6, you'll realize you have 6 shaded units,
1/4 of each?
Why?
which represents 6 out of 4.
Yeah, but this is 6/4. 6 times.
Yeah, so call the one that are not shaded.
Count the ones that are not
That's
shaded.
what she's saying.
But why do you shade these?
Because you're shading 1/4 of each whole one. Because you have 6 holes.
Sorry, 6/4. That's 6/4. You're right. You're right. You're right. I just got a lapse there. You're right. Like, I'm saying it right. I'm very not looking up on the right thing. 6/4. So if it's 6/4, if you had a quarter 6 times, that should give it the same. 6/4. So that's
On my
yes,
my real life example, children always like marbles and sweets, so I used marbles this time. I said Donna had 80 marbles. She lost half and gave 1/4 of the remainder to her little sister. How many marbles did she give to her little sister?
Okay.
So first she would have to find what's half of 80, then subtract it, then find 1/4 of that to find the amount that she gave to her little sister.
Okay, good. Very good. Anybody else? I think this is what I have in mind, so 6/4.
I started with diffusion. That's Anya.
All right. Yes, Anya?
I did division, but I didn't reach the real life example, so I'll just say that.
That's fine.
Okay, if we have, like, I could take 5 students and give each of them like a sheet of paper, and then ask each student to like cut it in half. So it will be, so then it will be 5 sheets divided by a half, and you get 10 people.
I start from the top again.
If you have students with a sheet of paper or anything that can be split into half easily, maybe I would have it already perforated in halves so they could just tear it easily. And right, ask each student to tear it in half. So in other words, we have 5 and we're dividing by a half. And then we count the number of pieces and we end up with 10. So then to be 5 divided by a half is equal to 10.
Good.
Okay.
How many halves in 5?
Exactly, or how many halves in 5, right? So then we would do that with different examples. We could do it with a half, have one paper shaded with a half, and then divide it by 1/4, maybe, and then you'll end up with 2. So we'll just do it with different pieces and stuff, so they could see that when they divide, what the outcome will be, and then I will introduce the algorithm so that they would see why you reciprocate and stuff like that.
Why is that reciprocate? All right, so even if I have this, how many quarters? This is something they can really just match and see. They have it.
Right, they can split up themselves.
Yes, they can. That's what you have. How many quarters are in this? Yes.
Right.
How do you translate this in terms of to the algorithm? Why do you reciprocate? That's the question of the day. Why is it that you reciprocate?
If I explain it.
I think I taught last summer one. Yes, I did.
But I didn't really understand when you said it.
Yeah.
But the way I understand it, it's different. Like when I try to explain to the students, they don't really get it. Because if you have 1/2 and multiplied by its reciprocal, it's 1. Right?
You have 1/2. Yes, but that's what I told you that. That's what I said. If I have, it's the same thing I said. It's the same, yes.
Oh, all right.
If I have 2 divided by a half.
Mm-hmm.
How many halves are in 2? Tell me. 4. Is this times this give me the same result? So it's the same thing, basically written another way.
Yes.
Exactly. Yeah, that's why I use the 5 divided by a half, because it will be easier for them to see that, hey, 5 divided by a half is 10, which is the same as 5 times 2. And 2 is 2 over 1, which is the reciprocal of a half.
Good, yes, it's the same thing. Same thing. How many halves in 5 is the same thing. So it's just represented another way. Good. I thought I told you that last. I'm sure I told you that last semester. All right, good. Anybody else wants to go? All right, so we're moving now from that to the next thing. Assistants, please. I need to show the document. So where do I go?
You want to show that you want to go to share screen.
Where? This one?
All right, stop share.
And so now we're moving into compute the square and put the square root of decimals. You understand that? So if I had to find the square of something and the square root of decimals, what are the common errors? Are we clear? The next thing, so these are basically what they expected the students to be able to do. Compute the square and square root of decimals. What are the common errors and misconceptions that you see? Is it calculator? All right, so we're saying basically, so sometimes the students don't have a good understanding. Let's say they want to find the square root of 16 point something. They should know beforehand that it should be 4 and something. Agree or disagree? But sometimes they give us some far-fetched answers. You've never seen that?
Yes, I have.
Yeah, sometimes they give us some far-fetched answers. So the idea is that they're not seen as a real square. So if you have 16 squares and you make 16 little squares and you make a square with those 16 little squares, it's a 4 by 4. So that is a square, but then you have the root, will give you the sides of the square. Is that clear? So if I need to find the square root of, let's say, 20, I should know that it's 4 and something, because it's between 16 and 25. It's not really, it doesn't reach 5 yet, but it's definitely more than 4. So that's the idea. You wanted to start on an estimate in their heads as to what the answer is going to look like. Are we clear, everybody? If you square 2 and something, you should have an estimate in your your mind that's going to be what? Greater than what? Come on, guys. Are you not understanding me? Are you not understanding what I'm saying?
Yes, we are.
Zana, are you understanding me?
I didn't get what you said.
I'm saying that what we want them here to do is to be able to, because this is really just being able to use the calculator properly. But part of it is that sometimes they're rushing and they don't punch the numbers properly. But the idea is that they should be able to step back and have an estimate in their head as to what the answer should look like. Agree or disagree? So as I'm saying, if they're finding the square root of 22, for example, then if you find the square root of 22, then they should know that whatever answer they're going to get, they might not have the exact value in the head, but they should know that whatever answer they're going to get is going to be 4 and something, because It's greater than 6. That number there, 22, is greater than 60, but is what? Less than what? 25. So you can have them first, now when you're teaching the concept of square, just having them join these squares and look at the lengths of the rectangle, the square. And it's a 4 by 4 square. That there, the 4 by 4, the length, that's the root. But the number of squares is a square, yes. Because that's why I'm on the phone. And then we have the square root of the, so we have the square root of the decimals. Of the square, okay, so if I'm squaring a number, if I'm squaring 2 and something, I know that it should be greater than what? For example, it should be greater than 4, but are you expected it to be greater than 9, for example?
No, it should be less than 9.
It must be less than 9. So we should have some borders in our mind as to what our answer should look like. Yes?
And what if they mean the fractional part, like 0.02 and 0.04?
Compare the squares and...
Because when they do the square, they may expect to get a bigger number.
Say this again.
For example, if they're squaring 0.04,
0.04,
they may expect to get a bigger number.
Ah, that's a concept that I don't know if that's what they mean by this.
Because it's of decimals. I'm wondering if we're thinking of just the fractional part.
Or just the fractional and not a, because it can be, exactly, but it can be 20, the idea is that it can be 20 and something. So it doesn't matter if it's 20 and something, it still doesn't reach 25, so it's still gonna be less than. So that's the whole idea. So it can be, yes, it can be 20 and 2200s for all I care. But the idea is that doesn't matter, because when they see decimal, they don't see they're not thinking all number, but they still should see that whatever answer I get should be between 4 and more, should be 4 and more, but not 5.
Yeah.
Following that? All right. Round off to a given number of decimal places. So because we're looking at rounding off now, we're going to take into consideration significant figures and rounding. What are the errors you see there? You're going to write this. This one is not so bad because most of the students practice using a calculator, but what we need to safeguard is having them estimate the answer before, so that when they see the answer, they know that it's not a reasonable answer. They can know, oh, must have made an error with how I'm punching the numbers, because this can't be the answer. We want them to be very conscious. But let's look at this one, rounding off. So we're looking at significant figure and how they round off. What are some of the common errors we've observed there? So we're going to write that down quickly before we need to finish it, before we go. What are some of the errors we observe when we're having our students doing rounding?
Round the relevant zeros. With zeros, they always have problems.
They always have problems. So I'm giving you 2 minutes to write. I'm giving you 2 minutes to kind of think through and write. Literally 2 minutes, because we need to go for a break. And I want us to look at the stats below, the report below, about how students perform in these. No, you can call it 4. And then online objects. And your lunch and drink. Lunch and drink? Yeah. Just go to the Emerald office and they'll give it to you. You want to collect hers? So much time, so much time. All right, you should be finished. All right, are we finished now? Zana, you were saying you started to explain, but I just wanted to give the others some time to think. So go ahead.
That's with regards to the square and the square root, right? I'm trying to finish.
You want to dance? So you still want to be able to see that you can carry on in the switch over. You can see
Go ahead, Zana. Misconception.
Pardon me?
Rounding the misconceptions you observed. It's the same thing, really. It's the same thing, you know. Yeah.
Okay.
Still an idea of rounding. It is, yeah, the same thing.
You ready?
Yeah.
Hello.
Yes,
hello.
I'm hearing you.
Are you hearing me?
I'm hearing you clear.
Okay. With regards to for example, when we give them 791 and we ask them to round off let's say for example to the nearest to let's say one significant figure. So to one significant figure, some students will not see it as rounding off to be 790. Some of them give you 800 as opposed to 790.
One significant figure?
Isn't 800 the answer?
For one, yes, for one it will be 800.
One is 8. No, not, sorry, instead of giving you 800, they give 790.
790.
Yeah.
All right. Any other?
Some might actually just give 8.
8. And yes?
Yeah, that one is very common, the 8. Just drop the rest of the numbers.
This one is very common. Any other?
700 as answer.
On the 7, depending on. You know what I realize? Even when I would say, if they have this number, let's explain. If they have this number and you say round up to the tens position, they will quickly give you this. Yes, sometimes they give it, they take off the 0, you know, but that's not the point I'm making. But as soon as I do this, if I do this, and they need to round to this 100 place, then they don't know what to do. Because they can't have, let's just see that's adding literally 1. Am I clear or not clear? You don't understand what I'm saying? When it's here and I'm asking to round to this position, they're fine because they know that they had 1, because that's what the idea they have in their head. They just had 1. They don't see it as it's a position, so they don't see the place but the concept to it. So when they get to, if I say round to this position, they will tell you that this is 9, they can't get any bigger. You following the point? Are you following me, guys? Everybody? 9 is 9. 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 9
Yes, we are.
They will tell you, Miss, I can't get any bigger. This can't get any bigger because there's a 9 here. All right, so how will we correct this misconception or these misconceptions? How would you introduce this topic or this the concept to the students? How would you teach this concept to the students? Okay, so let me give a thinking time. How do you teach students this topic so that they don't make these errors? You know what to think about manipulation?
Miss McCarthy?
Are you ready to go?
Can we use a number line?
All right, tell us how you'll use that number line.
I would 791. I'll draw a number line. I'd have probably from 800, well, from 700 to 800. And
are you counting
it's
exactly?
From 700 to 800, and I would identify where 791 is on the number line.
But that would be a very long number line.
Yeah, but I would have them estimate where exactly. If halfway between 700 and 800 would be 750, right?
Okay. So right now the 750.
So, right. So therefore, I would tell them, let's try to visualize where 791 would fall on that number line, and they would probably tell me closer to the 800.
Okay, very good. Very good. It's a good method. Are we all following that? She has a number line, 700, 800. 750 is somewhere there. Is it falling closer to 700? And that's the concept, you know, that's the concept. When I look at this here, this is exactly the concept. When I look at this here, this is really what? 30. So the next one is going to be what? 40. When I have 35, where is that falling? It's falling right there in the middle. So when it's falling in the middle, we give a benefit of the doubt. But if I should have a 36, it's falling between 30 and what? 40. Is it falling closer to 40 or closer to 30? Is it falling closer to 40, isn't it?
40.
Yes, so that's the concept. So if I have this, if I'm rounding this position, the next one is what? 100, isn't it? So between 90 and 100, if I'm rounding, this 91 here. Where is it closest to? The 90 or the 100? Are we following that, everybody? It's closer to the 90. That's why this is 790. If this were, it would be falling closer to the 100. That's why this would become. Following that? Following that, everybody? Everybody with me?
Yeah. Yes, we are.
Sabina, do you agree with me or not really?
I agree.
Okay. So if we're just simply telling that this is a 1 and you add 1, that's the idea they have. But it is where it's not a continuum. Where does it fall? Does it fall closer? So if I have 2,000, if I have 1,900, is it closer to, and I need to round it to the first significant figure. Is it closer to the 1,000 or the 2,000? All right, it's closer to the 2,000. So that's why I don't round it. My answer is going to be 2,000. But if it's 1,200, it's closer to the what? The 1,000. So my answer. So if you put the concept like this, they won't give you 8. They'll see that something is wrong. They will not give you 8. For sure. If they give you something wrong, it will not be 8 and more than 7.
Yeah, okay, so
and you could have them draw the number, and then they start to look for range. Where is it falling between? Where is it falling between? Is it closer or further. So when it's like, if I have 1,500, no. It is right there in the what? In the middle. Once in the middle, you need the benefits of the doubt. That is why you round up. Are we all clear?
Yeah, what I was thinking.
Yeah.
Yes, Sabina?
What I was thinking is that they have to realize that when they change into the number of significant figures, they have to look at the whole number itself. Like 791, the whole number, 791. Instead of thinking about the digits like individually, because I think that's what they do. So they quickly rounding off and forgetting about the rest of the digits. Because if they would thought about 791 as a number, they would have known it could have never been 8. And I think that's one of the biggest mistakes.
That's true. So that's the reason why. That is very true. That's the reason why. But if I'm rounding to the position that I'm rounding, you have to look at that place. What's the place below and above? That's how you round. You look at that place that you're rounding. What's the digit there below and above? So if I'm talking about 97, between that 97 you have 90 and 100. So you also have to focus. So yes, you have to look at the entire number. And when I'm rounding, I'm looking for where is it falling between. Okay? Very good, Sabina. All right. I now want to show you the stats for this. This is important. I want to show you the stats before we go for a break. I want to show you the stats for this, and then you're going to tell me what you think. Okay. I don't know what to do. I just want to fill up my video. This is it. I just wanted to put your picture on. Oh, yes. And then here. Blank screen, grab the remote. Yeah. Alright, this is the stats. So this is question 1, and this is the stats. The question was attended by 99%, so most of the students attended this question. But look here, 8.2% of whom earned the maximum available mark. But what do you think about that? Isn't that alarming fact? 8.2%. That's just a little fraction question. Square and square root. So I'm going back through it, just to practice here. The fraction, square and square roots of decimals. We didn't look at divided decimals. We need to go back to that. Rounding off and solve problems involving cost, price, taxes, profit, and percentage. We ought to look at those two when we come back. Yeah, we missed those two, but we're going to come back to it. So only 8.2% scored maximum mark. What is that saying to you? These are basic concepts for the challenging topics. If I don't master this basic concept, how do we expect to teach on the challenging topics? What is this statistic showing you or telling you? Everybody, somebody, anybody. What is it telling us about what is happening in the classroom and the students' level?
Basics, their basics need to be strengthened. Their basics with many of these things. They need to be strengthened because, I mean, you might think, geez, a basic something that man learned that already in a grade 2, but can you apply what you learned in grade 2?
It's how they learn it too.
Oh, yeah.
It's really how they learn it. And some of us think that We don't teach lower school, and
So
therefore we don't need to.
know.
But we need to. Sometimes we really have to step back and address these issues before we really can teach the students the gradient and the linear programming and all of that. We need to step back. Eventually we're going to get there, but as we get closer to the section 2 questions, you're going to realize that the section 2 questions, there are different concepts that they just pull together. As a reader, you're going to realize that. And that's the reason why these concepts, they have to understand them properly. So like when they reach at the linear programming, it's just understanding how to graph, to plot points. It's real. So that's the concept of plotting points. That's the concept of inequality, understanding inequality, the concept of gradient. So if these concepts are not learned properly, then they're not going to be able to do that. Are we clear? Anybody want to add anything? Anya, what do you want to add? Anya, Sabina?
Yes.
I don't have anything to add, really.
Okay. What do you think of the stats, though?
I was saying something. I don't know if Anya wants to continue.
Go ahead, Sabina.
Okay. I was saying that, well, I was just going to tell Ms. McArthy, we did have to look at the CSEC report for, well, I looked at it for last semester when I was doing the other course. And this is 2014, but it has been happening for so many years. And what I'm thinking is, I don't know, because the same way we're looking at it, the teachers who teach that course and teaching students for CXC are looking at it. In my opinion, it's possible that they feel that this question is not significant enough, so they're not going to place too much emphasis on it because the students continuously perform poorly in that question year after year after year. But for me, I feel the important thing is that not being able to do those operations, it affects their performance in other areas in mathematics, and they don't realize that because even at tertiary levels, when they have to do percentages and other topics, consumer arithmetic, other things, those basic foundations that they don't have, they actually fail the question because they cannot do decimals or fractions or percentages, and they keep carrying it on. So maybe in the CSEC exam is the first question, and it may just be about 3 marks, and maybe that's why they don't emphasize it, but it also affects the operation in other areas of mathematics, and maybe that's what people need to think about.
I agree, 100%. That's the point I'm making. If they don't get, yes. Yes,
Miss, what I was thinking too is, if you take a look at it, some of these concepts are not concepts that are taught at but all that is not being taught at the secondary school level. Sometimes, especially at the secondary school level, we expect that the foundation is laid at the elementary level. Because if you look at fractions, children start learning fractions from a tender age, maybe from grade 1 or grade 2. And very often you find that coming into the secondary school, and when children are already taught the algorithms a certain way, you find it very difficult for them to break away from it, whether it is taught properly or not. So at the secondary level, it becomes very difficult to get the students to, one, even like doing the subject, because they're already coming with the conception that, okay, well, that is a very difficult subject, I'm not interested. And two, the steps that are already set and instilled in them. In completing an operation, it is already there. Even if it is wrong, the students are already set in their way. So sometimes it's not that you don't try to correct it at Form 4 and Form 5 levels, because trust me, I teach the grade 10 and 11, and we do not teach fractions because by Form 1 to Form 3, we expect that students would have had that these concepts covered. So we basically focus on the core areas like algebra, the areas that we know that CXC will be testing. So I think these are some of the misconceptions, especially going into preparing these children for the exams that we need to face, and maybe we need to deal with it very early as opposed to by the time we get to Form 4 and Form 5.
I find that, many times, well, I heard someone say it once. Hi, everybody, it's Dina again. With CXC and like GSAT, well, let's just say CXC now. Those exams where you're it's a standard procedure where students have to pass it so that they can go to university. And so when they say that, okay, I just need to get a 1 here or a 3 there, and if it's a mind block against maths, please, I just want a 3. And then they're just going to go in there, they're going to go through all the past papers. They don't care about the steps. I had to say to someone, stop looking at the marks. You see 3 marks, you're saying, but why can't I just write 3 lines? I say, who knows, you might write 3 lines, and you get 0, you write 6 lines, and you could have gotten that 3. And so they're saying they want to pass. So many times they don't even remember method and stuff. And you're saying, but the steps, you have to write out all that long steps. And I remember from such and such, I could have just write those 2 things, and because they want to pass. So, you know, sometimes it's actually
create an exam, just a test culture.
In their mind that I just need to pass the test. So let me just go back over what I practiced and just write that on paper. So they're not thinking about, do I understand this?
But that's a good thing, is that we are driven by test results. We are really a country or culture or a set of people in the Caribbean. But a world per se that is driven by test results. But the major thing I want to say, Zana, I want to address what you said earlier. Yes, Zana, you are perfectly correct. Because when I was in the high school, I did not teach fractions. I did not teach square and square. I did not teach all those things. But the truth is, you know, the saying that if I know what I know, if I know then what I know now, if I know then what I do know now, I would have made a difference in how I approach the teaching of math.
I agree. Mm-hmm.
So the truth is, for me right now, if I'm supposed to teach in the high school and I'm assigned grades 4th form and 5th form, grades 10 and 11, I'm definitely, if I'm teaching, it doesn't matter, even if I'm teaching algebra, the fractional concept, I'm introducing the fractional concept, I'm still taking a model. For the ones who can't who can't do it abstractly, they can I can still take a model and still, it doesn't have to be a fraction lesson, you know what I mean? But it's just a 10 minutes or 5 minutes that can make a whole lot of difference to show, let's look at this, let's do it here, let's add in, okay? So if I'm adding a half x plus a third x, we can, isn't it still algebra? All right, use the fraction pieces. So we can find creative ways to take that 10 minutes to really start making a difference. Because look here, if not, we have to realize that the solution starts with us. Because everybody's going to point fingers. As I said before, when I was working, so this is why I'm saying, I'm taking a stand to say the solution starts with me. So when I was in the teaching in the high school, I used to blame the primary school teachers. No, they never do anything with these students. They don't know nothing. Now I'm teaching at the college level, university level, and I'm saying, no, sir. They never did nothing with the high school students. Nothing was done. So I realized that. So now the Ministry of Education, they blame the lecturers and the teachers. The lecturers not doing nothing with the teachers. So you realize it's really a cyclic, it's a blame game. So we have to decide that I, whoever I am, need to start, the change start with me and in my classroom. So, as I said before, if I knew that, I would have done things differently. Yes, Zana?
In conversations with my head of department, I think one of the things that we, especially the algebra test, I spoke to her just last week. I was having a conversation with her. I was saying there are some things that I learned, and I would like to at least to share it with my other colleagues so that there are some things that we can adopt in the classroom. Because algebra seems to be another problem. We have a very huge problem. And I was explaining to her that, you know, we could probably use some of the manipulatives that I learned so that at least we could try this year, starting this the new academic year, to see how well we can, because if the train can understand these fundamental concepts, maybe like you were saying, when they get to linear programming and the other topics, it will be they will have a better understanding.
That's my point. And for me, I also find it very alarming if these are the basic things, and only 8.2% can score maximum. And they've been doing this. So whatever we're doing from grade 1, come all the way up to grade 10 or up to grade 11. So let me include that. So how many years of math is that? Wasn't working. So all of us have failed. That's the conclusion. Because they've been doing this for so many years. And you can't do this after, how many years is that? 6 and 5, 11 years. I've been doing this for 11 years. And I'm still not understanding what we are doing something wrong. That's 11 years of doing the same thing because of the cyclic curriculum, 11 years. Somebody have to stop it, and somebody have to interject, you know what I mean? Okay. All right, so we're gonna take half an hour break so that we can have our break and then we come back. What time is it? Okay, 13 past 4. So we come back at about 4:40 almost? 4:45. We come back at 4:45 and we continue from there. We're going through the report. We're thinking of what we can do in our classrooms that will make a difference in how we teach it. And I have an activity for us to do. I hope that we get a chance to do it today, and that's Thursday. All right? Okay. You may go 4:45. I said 4:45. There's a microphone on there. That microwave over there.
Yeah,
Where now?
There are no my comedies. Seriously. I'm trying to look out for your good man. Where's the cream? I don't know what to put on my microwave. I don't know what to put on my microwave. I'm trying not to get that big.
You're not going on. Yes, it's on. What is the liquor?
It's not going on. Actually, a friend of mine said the same thing. You're not going on. What's your photo day? Yeah, because it's supposed to talk. No, I have to work on full education. I'm not focusing on it. And what? Yes, I'm not food. Just take it from me and done. It's a lot of French stuff.
What are you trying to do?
Yes. You will feed on French.
Are you all the French?
I just had some kind of he's nervous and trembling the life of his body because his results on your report.
Oh. What grade?
7. I'm saying the word that some grades might be high, some low, especially in music. Music was higher. And he's saying, I'm afraid that would be low because they gave him the music book list. The list, they added the textbook family to the book list date. Okay. But he had an issue last term where his music grade was very low, and the other grades were high, so his average.
Oh, so no, the average.
So we were worried about his need.
I can imagine.
But you know what I tell you? He said the afraid that he's still not going to get married. All he does is go home and take it. He said he doesn't see the need for bringing him over and studying a week before the exam. So that makes sense.
He's supposed to start doing
Even Jesus knows that. So when I saw that, that's his mindset. Right, man.
Yeah, not great, right?
Keep up with your homework.
Run it out, party.
Keep up with your homework and keep up with your notes. Why should I sit up with Jesus? I'm going to evening classes and I'm going to school to learn for it. Take time with me.
I said, okay, you want to do work at all? You work at all too. You have an extra? Tell you need some parcel.
There's only 1 year to practice.
Oh, well, you don't know that. I think that is the best answer. I think it's the best thing to do in terms of figuring out what I like and stick with it.
And when I got to eat, I know that reading didn't bother me too much. I saw some lines in it. The political economics never catch me. The industrial, the international trade, something them never catch me. And subjective ones never catch me.
So why you didn't go straight now?
I got to back there outside, but
but I don't drop marks out here. It pays though.
It pays, but I have to do really good. I think that way that first grade. And also I did a survey. Someone from my high school said her roommate did it. And they had to take her to the hospital and had for her exam.
I hear it's terrible. It's terrible.
And just the scores and pass rate and
it's terrible. You have to pop up nice.
So I said, why not? But then I said, I've been doing math like every day. I want to apply it to something. I tried accounts. I said, oh, it's not so boring.
It's terrible.
So when I thought statistics and econ now, I saw the research and all.
Proper mindset. Proper mindset.
Mindset what I want to do is just keep up with class. Because he doesn't hate school and stuff like that. He really likes learning about tomorrow.
But it's not his literature learning.
But in the English literature book, the weekend before school starts and they finish it Friday.
Well, he's learning a lot.
Yeah, he is not 50% smart and all, but my father doesn't even like kind of stuff. So he's saying he doesn't want anything that can get it out of comfort zone.
And yes, very, because if you get married, you have to work hard. I think my issue is
he did that already. He said he got 90 for maths, and I said, listen, no less than 90. I'm in 3 more. He's like, you said no less than 90, I got 90. And this, I'm like, you need all of this stuff? You said no less than 90, and didn't I give you what you asked for?
my issue is at the point where her daughter, she reads a lot. The fact is, when you read a lot, you understand know a lot. Yes, when you read a lot, you're going to know a lot. That's the whole thing. So she doesn't feel like, well, I know what I know, but the average 59. She passes it to the camp now. But her father knows, she's trying to instill in her that when it gets to a certain level, it takes a little more than reading a lot. You know what I mean?
Well, the teachers were telling my stepmother, the guidance counselor was telling her to give my room for failure. My stepmother is like, don't do that.
I think it's important to let them feel as though, like, if you mess
so this is a nervous feeling is the first I've ever seen it with him. So I'm saying, nice.
Something to be nervous.
I've never seen that with him. Even Jesus said he just finished it and come home and fine and cool. Results, and my father was so shaken. Normally, he asks us, which school you want to go? Come tell me. Let me write it through then. Because we tell him, and he has many kids. One child he had to choose 5 schools for. Because which school he wants to go? I don't care. Don't matter. My father was there saying, I can't think of that. So he said, I said, Daddy, how did you choose? He said, we didn't have to tell the truth. One evening I was dropping. And you guys were talking about school and stuff. I remember when Monroe, big sister went to Hampton, I said, all right, Monroe, boarding, discipline, and like, I wasn't even thinking about money part. And then some money too went there. Mark, what it's done, it's still about, yeah, let's bring on them in the parish or see that way. Right. So that you never think through, you never, so you didn't know what to do to try to set any school. So you just come over there, oh, the pass from Monroe. You're not. Just a school. Just a school. And one of my friends, her mother teaches, she teaches for about 20 years now. And when she asked him that at church one day, she's like, I don't know, I study what's up. My first choice, Mom, go, you don't want to pass what's up. It's like, it doesn't matter. Because I tell you from about 8, and really go to the best.
Yeah, because I went to a technical high school, so it was let me say, prominent high school. And it's about, I realized that it's not really about the school.
And he was transferred because it was expensive up there, and it was when my father and my stepmother didn't get divorced. So, of course, that was no drama, but it wasn't. Yeah. They just wanted him where, so he just said it. He said, hey, I don't mind waiting for one here in front of you. Choose a school that his best friend passed for from technical.
It's a technical high school, and suppose, like, I love science. Huh?
Love science. He saw an MRI of my brain, and he's like, oh boy, I want to study brain now. Be not here. The brain shaped as long as your head. But the complacent thing, because they're doing that with him now, like using him. Even when we went to Monroe's orientation and stuff, but like I'm sure half of you boys in here were head boys. All of you were head boys stand up. And he was just sitting there and he's like, I'm sitting for a reason. I'm sitting beside. Then he said, stand up. I said, okay.
Or those things are not as important, you know?
And that's sometimes get used to it. But he was saying teachers are rude at times, and here teachers telling children about going to places where the sun will shine and stuff. And so he said he did that with teachers and students with the first word. That's just it. But we don't want no teacher to be in the spotlight and say, oh, he's the best performer and stuff like that. They get complacent. I told him all parts of his body that I would do stuff. He asked me one day, you're going to miss out so much of me, I think you should feel me from me. So I'm scared and nervous to tomorrow. I'm sure it'll be fine. I told him I was saying, but whatever. You don't do so well, you know what you have to do, right? So yeah, work harder. Yes, I went to also for traditional high school. You know, it's more like grades in the dirty bag. Some of them go, I think what some teachers know, but I never even learned in a certain class.
I think that some persons peak early. Because when I was going to, I remember when I was going to private school, the students are going for a branch from class. By the time you get to high school, they started, well, I think that I'm in primary school, all I think about is school I'm playing. I never grew up in primary before strict on me into the world. I don't know what school I'm playing. Like,
I never had to study for no holy like Jesus had no study. So that's the thing, my father and my stepmother are kind of different. She doesn't want him wasting. She said that she sees him with potential, but he just loves games and he just watches television. And she's saying he did as a poor on a literature exam. And she was like, mad about it, same thing. And he read that from now until yesterday. And he doing poor on a literature. Why couldn't he go and review the book? So well, maybe he read it all, I read it and then read over the book. Sometimes twice, so you get bored. So she's saying she did that. I don't know.
student because the roles learner, the persons who are the best memory perform better in primary school. That's it, don't it? But as they grow older, you realize that they don't do as well because I mean the persons in high school and primary school should be at school with this subject. Like she barely, she didn't do better than me. Like she.
I barely. Even the vice principal shamed me, said I didn't have enough ones to get in sixth form. And then students know about it, but I had all the subjects, so the principal had to apologize and stuff, and they took me in. And a lot of my friends didn't feel like putting in their reading. Them said, couple of them in there, like, they have a master's in what? And something that when enough people can have listen, like, you need to look up in the door and put it in my face. Like, oh. And I was treated badly with some things. People, they don't know what I was going through. My family was going through.
It's just exactly, sometimes it's environment.
Then, of course, I felt hurt. I got out of the room, everybody said we get shamed, and I was crying. Go to school in the day when everybody's supposed to be in uniform, and I was just at the expense and my clothes because you get through for me. But,
I remember my grade teacher, like I said before, I think that because it wasn't the focus in my household, I think my mother was just, she had friends who were very cleaners. Because that was the thing, she worked. My stepfather worked at the time. She's so busy that she couldn't time. She didn't have time for the book and down for that. She just wanted to clean and eat it. I think that because I'm from the country, they could have heard simply thing. Sitting, oh, you're clean and you eat. You're all right. I'm sending to school, you're all right. So nobody was there to tell you what to do when you work, So you come in and I don't know.
you grow it into innate ability of saying, okay.
It was really.
But my father,
I see that was planned.
Yeah,
exactly.
he was.
He said, I'm going to do this with my life. This is what I'm going to do with my life.
Nobody's super brilliant for too many people. And he got some opportunities and stuff, but stuff back in traffic.
I was an friend.
So that's why he always just tell with young goals, and that young goals and
things will happen to you and anything.
Don't ever people don't act like you're. As a matter of fact, he keeps telling me that I need to have self-confidence when I don't have that. I realize I don't have it.
That doesn't seem like you.
Then you say I need self-confidence. Like, why? It makes me go overboard and say, oh, but sometimes.
Self-confidence is different from being narcissistic, just arrogant. It's different. A confident person is somebody who is going to be in the face, blah, blah, blah.
Yeah, like, of course, I did political economy, and I wrote to myself, of course, so the rights, and so because he said I wasn't nice. Sometimes even in the class, with no big words, I mean, so the problem is, you're watching, and you probably listen to people got big words and all, you don't want to dictionary but not what you say.
And you can imagine, once you learn, a lot of people talk very, a lot of big words, they're foolishness. No thinking, they can't say, they're foolishness. Big words of foolishness.
But one of the things I went through on this too, the vocabulary. When I spoke about vocabulary, I was saying same thing like you said, soft, simplify, equation, expression.
Because at the time, I think it's hard for us to admit as teachers that we're not remembering. Yeah. If French can look good, I think I'll take French.
This is going to be fun.
Whatever.
First place fat region.
Yeah, I feel like everybody just kidding.
Sometimes confidence because I have a friend who was when you're from country, she had some experiences from life stuff. And I tell her, listen, One for your first class and work hard for it. Don't stop with the thinking that you're not good enough, you can't do this. And it's just like, so don't compare yourself to me and all the foolishness. And he should miss it by about. And I say, hey, you never get it, but guess what? You realize something? You understand that you something like it. Don't you?
Here, my friends went to Belgium. My husband was and it was the top of what college school at the time. Like first you get a campion, then there's a campion. And look here. My friends they call me and ask me to answer. Is that good? Like,
they went to these books back with the monies.
I don't really know when they work and saying, look here, insert this, you can't fix this, to this, to that.
And when I reached university, I did play with Campanites, Wood Mirror, and in market all kind of people. None of them in a business, but we sex in there. People are afraid we get 41.
Trust me, some people peak early because there's people who really go to school, some of the class, and just who didn't have the best number of the time, plus parental guidance in terms of certain our home where you know people push you, like encourage you and force you to do.
Some students they can go to evening class every evening, even on weekends. Can you afford to send your child on weekends?
Not really.
Some students, they probably have all of the textbooks, then you only have 3.
Not sure.
When even as I was saying, transferring the money, transferring back here, transferring back here, you stay at that school because that school don't have the right to get them out. All of my friends, one of my friends teachers was taught there, so listen, missing grades, let him grades tell you what to do. But don't if and ask them. Don't ask me, you want to be transferred? Alright. Because you know, because we'll transition again in a new school, new friend.
Yeah.
And a friend of mine said, it's the school, right now, the school where we used to go, like the top school, they're my big maths teacher. You know how much I'm being able to pick me, them, you can't even understand 1 + 1. Like, what?
Yes. So, the students, you have to have that drive, know what you want. The personal thing.
I have a friend who, you know what I mean? My friends and stuff, and so campaigns and the comparison. I'm like, stop comparing yourself, guys. And I hear some of them talking about other people that might pick me up campaign, other people. I'm like, why? Somebody on campaign did something, you know? And then they probably think I'm biased because I have friends on campaign. I said, the friends I have from campaign, they don't even care. They don't care is when you guys put them up now and let them feel as it. I'm like, stop it, they don't care. That friend I have them don't care nothing. Just come on the tree and study over the university because we know business no will never.
I think I need to like stop focusing on I went to. But for me, I said,
one thing I do is give trouble because my boyfriend went to Women's and I went to Manning the Women's of Florida, which one older.
Oh,
to the oldest school. That's the trouble we give. Yeah, but they were great, so they decided to them just stop things like in the class.
I want the best memory for spending of time, go memorize, go
So I just don't worry, but I know it will be a best time. Don't get with the vulgarity and the flatness and I think my father feel like he want the teachers don't put on the stuff.
be careful.
He
So
hates that. He hates that stuff.
when you have an accurate estimation of time. You can find it for the wise. You seem like a very wise person.
Probably the wise. He got bad treatment in Sudan and he got some things up for it. Some racist kind of stuff happening. principal change over. They use them. That we could draw very well and stuff. Just examine all that. I'll probably do that today, man. People say not to do that. They use stuff in there. Still reading right now. Is that my second? But many, I used to say, see, people read so many young ones. Care. And me fling it on him. He said, all right, you're gonna shut it.
I need to share something with my stepfather. He didn't get formal education, but even in my stepfather's like in terms of how to speak straight English, in terms of ability to reason. If I hear my, if I hear my stepfather read in top of things, full stuff on positive, I know that.
Yes, my mommy was saying that she wanted to be a nurse, but family issues again, didn't get formal education. But when you hear she has taken care of a lot of elderly people overseas. When you hear things about certain things, they're like, interesting. You can just pick up that. Yeah. But it's like common sense to her. She's like, you know, when you have this sore here, this sore that, what? Now, like, but we have to search from Google to check what to use and what to.
I think there are a lot of people naturally. And that's all we need to give God back because where there are opportunities that are provided to us, rather than, oh, you're bright. Oh, man.
Because of that, I looked at and I said, I was never known pops. I was never known. Just maths, you know, very like, you got a calculator, you know. Because I used to go to the one camp, but right, look at so then my teacher never gave it to know. Go home, go sit down and listen to music and maths. Physics, the highest never get a 66. And it's when I took a Jinko biloba the night before to study. Some energy thing that I will never try again. Imagine that. Yeah, I know. I thought every time something man. I don't really know whether you can someone but they didn't last you. Someone told us. What? No, she didn't last you. Oh, they said, sometimes they try to put it in the program or something. Maybe they're shot on me or something.
So you guys basically think last year's students was a good program free? Free? I think so.
Well, yeah, the famous ladies, I don't see anything up there, so I don't want to pay them in the same online. And I was told to, like, if I don't see the school fee up online, do not pay. Not online. Not up and do it only $38.
Then what if I thought mama
Miss, when I graduate, you know what I'm doing? I found in the paper that's in my hand. I'm walking down with. I didn't even care about Dina Spence first class. I didn't care. It's my paper there. On the paper blank. So much people beside me happy with me. When I went to the office, he said, "Oh, you owe the university $250." So I said, $350. They said, once you owe them $50 or more, you can get to give you. Shocked that I couldn't move. Is that seriously?
I've never got it. I think I'm going to get it.
No, that one when I went to a master's one, I missed the distinction because of a failed a course. And it wasn't out getting and stuff. My father said, "I don't know what my mother was wondering, should I come up here? And so, when are you going to go pay my shows now? That one time, that's enough."
I think that was the fun of life.
Yeah, money.
I was trying to get my house at this time. But I think I was a good PhD. That's what it would be like. Okay,
that's
kind of
So, masters, I think it's probably only persons who like. I think it's probably one, and some persons didn't even know when it's master's graduation. Some of us just the last day of school, last day exam. run. I don't think some of them pick up them vehicles. I'm like, because it took me a while to pick up that vehicle.
I picked up my quite early because
No, not like a long while, but I did it. A friend of mine did say, oh, you're not. You put up my head again. I'm not in the master's program yet.
I said I knew it.
Oh, you did the education there? Master's in education and teaching? Math specialist?
Not in it.
Oh, math. I know somebody will be doing it. But many persons were there, but we really want to we have to something to teach them. We just say that. But I don't tell them what I do for them.
What's this guy? Medication? Medication every day?
Yes.
You tell me every day?
Once a week. Because a lot of times, say, I just sit on my doing it after doing it.
So you're taking every day to do it. I'm sorry.
Not to take it until, let's say, 1 to 2 years of me not getting sick. It's 5 months now, I'll be fine. So then McArthy 25 too. So then I just set my mind to it. The lecturers are like, you know, you sure you don't want to take some time off from school now? So you have to get your
So you were working part-time?
No, I was in school full time. I was working. I didn't finish because I was in Western Campus. But I came up fully for econ and statistics. And he told me I could do a major, go over in the next semester. I said, no, I just want to finish everything in the summer. I did that, but the September master's started, and they're like, you can't apply again, you can't up. But they're like, just apply now, you know. So you not apply. And somebody in the program, an administrative person, say, young lady, apply. Stop foolish. And I applied, and I was
So you like, oh, in school because you know about doing this now.
yeah, that's what they did. You said, stop over this thing, and they're like, yeah, chat, you just a chat. I'm so seriously, Mr. I'm like, you're just chatting. You were sick and going to school and you get the opportunity to go away and go stay home and you didn't take it. Just take the plane.
Them always joking, I should go for a PhD.
Yeah, but I don't want to be fun. Econ too broad.
So it's one to the team.
If I don't do it in econ, it has to be a certain part of econ, like a statistical part or something. Even maths education, I found about that too because many people never know education about the econ. And many brilliant people.
They're too young to stop. You know, when it's not
but
it's like your fault in just.
Yeah, my doctor told me so. He gave me the approval. But he said to me, don't. But when he see me having those for the PhD and the GRE and all that, he said it is not something you want to get married with. Like, I want to take the other life. Another lecturer of mine, she said, listen, I think I have been 5 years of time. So when she loved, she just did a broad econ. Like, he fought apart. It's like the doctor, I know he did medicine, but he picked out neurology.
Mm-hmm.
So I thought about econ and I spoke to one of my lecturers. He told me, he said, listen, don't make anybody tell you that education isn't key. And he normally send me some TED videos. These are all in fun. But he told me, go and do it. Many lecturers would be like, oh, do the PhD in econ, so of so.
Think about the position of PhD.
Yeah, that's what like my doctor said. You know what you like.
Because look about for passion. Because I just finished my course on his recitation now. And it wasn't just it was starting working and studying, but I think that next year, come next year, taking a break and just in school. That's it.
And the thing about like with me,
just need to be
what I did my paper in my econometrics paper, and it was funny because I only had
come back on what time?
It was like
Let me look at the latest one.
not here. Doesn't send me anything. I don't know the pockets. Email, sorry. But some people are emailing. Some people are emailing. What am I emailing from? And you don't know that you're seeing stuff about. What may I say? It's them say they. Some people using emails with them scamming. And they're like, everybody can just email me and don't hear from other people and those kids. And you will tell me about, oh, your family just had this and that and such and so forth. So you can donate such and so forth. Them send us something, not no, but sometimes them send us something like I'm not sure I am.
Oh, my water all the way there. Oh, come on, let's try something.
All right, we're here. Everybody's here.
Yeah.
Okay, did you all have your lunch or should I say dinner? You all have your dinner? All right, so we're back. Anybody knows what happened to Tasha? Caroline, are you there?
She won't be coming, Miss.
Caroline?
Here. Colleen is here.
Okay, just checking. Because you're always so quiet, Caroline, I can hardly hear anything from you. All right, so we're moving on. The next thing we're looking at, I'm going to look at just division of decimals, cost price taxes, and then we'll move into algebra. The main thing I wanted us to finish, to be done with this in the first half of the class, so we could move into algebra and see how we could use our tabs and stuff. to teach factorization, and I want to do a nice little paper activity with you. Anyhow, so quickly, I'm going to ask you to do this, but because I want to move very quickly here, I'm going to ask you to write down all the misconceptions and errors that students usually make when you're doing this division of decimals, and write down activities or steps that you'll take in addressing these errors and misconceptions, or how would you teach this to prevent students from making, in an attempt to prevent them from making these errors, okay, or misconceptions. Clear? Clear, everybody?
Clear.
Good. All right, so I'm giving you 5 minutes.
Oh, okay. Like they're looking at the 8.5.
And some of the teachers will teach them.
Yes, I saw I know, but he was horrid. And then he was super smart. He was super smart, and he was drawing a graph. And he said, "Well, you can't get his graph, and he can't like sort of like but there was an error." But he was so lagging the hurry. He had no 0 point. So we started at 10 points. So there was no 0 point. So I'm like, no. He said, "Well, because my God starting right here, it's supposed to start right there. It's not supposed to touch them." So he knew it. I'm like, come, I'm like, calm down. You can have something you lift up, but he was using Excel. I think that's something. Person Excel.
And sometimes even smart, the person that thinks smart, they're good at a good memory, they can sort a lot of things, but doesn't necessarily mean they understand a lot of things.
My students, I know them from. I tried that already. I'm going to try it when the exam. Geo so much. I was just the Geo brand. This one maths vocabulary not so strong. I want to use software in there and they like they think once you say decimal, turn it into a fraction.
I think it's wrong with that.
That's not how I think.
Exactly.
No, I don't know what to say. Once you say yes. But you know what's there? The error, like when they see sometimes they put 1 over 0.05. Really? No, I don't know. Like it's like okay, let me get 0.05, easy 5 over 10. 5 over 100. Oh, like them told that fraction, that's already wearing like this is a fraction and they're like 7 over 10 and they're like a counting like divide by 3 times. That carrying over. You know, so it's like what do you just no, I think it just needs to find the shortest. Oh, shortest. They didn't necessarily define. They create their own shortcuts. Teachers used to tell me that. They wanted to pose and over 3 times.
Just a whole. It's a whole.
But that is a What do you know for that? I was speaking about it. Or it should be after the not before. Oh, yes, that's not easy. I'd say you have X is a X E. What's like another thing? That's just should write 13. Yeah, I don't really write to look at that. Okay. Just as mental. Yeah. Yeah. It's that what does it mean again? It's a set of real numbers. Yeah. It's a member of real numbers. No, it's set a member. It has a name. The items belong to the set of real number. It has a name in the song. Yes, that's what misconception of numbers. 0.10 divided by 0.2 is equal to 5. Yeah. Some things are really
adding money to bracelet. Yes, get inside. Get inside. They gave you orange juice on there? Sorry, they only gave you no, I like the plain one. I'm not just a oh yeah, this I really like it, but they have two functions. Somehow I think that needs to be water though. It's water. So I won't take any more drink. I'll just take some water. It's water. As opposed to very hydrated. These things that would go to the class or we have a test. Miss Officer, you just need to force it. I'm going to send it.
I will finish or I need some more time?
How would you approach teaching with this small?
Then I can show you the
because you see that if they understand the fraction concept properly, then once there's less than a fraction, they're fine.
But you don't understand nothing about it.
No, because if you teach them fraction,
oh, you mean if you go to the first two already?
Fraction is a person for that definition. They understand fractions properly. The fraction before the rest of the fraction.
You're thinking about if they did.
Yes, so once they understand fractions properly, that's why
you should be good at it.
yes, all the time, interconnected.
Shortcut, we do the same thing. You should understand this shortcut. Use a shortcut. The shortcut team wouldn't be a tree long.
No. I don't think you please understand.
No, that's what I'm saying. Okay. So rather than do that, then you know it's a fraction.
Okay. So you know it's a digit that moves.
Right.
I think that's what you guys are.
I was saying instead of making them do that thing. I used to do that.
He's really surprised to give a over first.
Oh, can you go?
Yeah, exactly.
All right, are we ready?
Oh, I'm gonna put a screen on first.
Not ready?
Can go ahead.
Okay, give me a second. No, but what I see yeah, but what are they saying?
Oh, they're going to see the.
Oh, you can share.
Oh, you're sharing.
Okay.
Hello, someone help.
Let's see the board now.
Help. No. Help.
Let's take this off from it, please. The background is black.
That's
And then you have a remote second do yourself.
that is me.
Oh,
I figured out how to do it. No, I did now.
that's good.
Yeah, you should be.
All right, guys. All right. What did we come up with? What are some of the misconceptions? Misconception first. You have to tell me how you use the money, then we get to the proper.
I'm not saying anything money, I said misconception of using money.
The shortcut. I don't know how to explain the shortcut. But that's like you have 0.05.
Misconception then.
That's a misconception.
Okay.
All right.
I think it's one of them can be moving the point, the decimal point.
Okay.
That's my shortcut.
Okay, moving this one point.
Thank you.
And some of them remove it.
So you have
Divide by 1,000.
we do that, right?
And sometimes I don't know which direction to move it to.
Yes.
Although it's not good to teach them like that. But you see, you put it in their heads, then don't remember. Should it be left or right?
That's how.
But it should have a very good.
Any other misconception? You figure out how we're going to what is wrong with you and using money?
Yeah, because when you use money, I realize that apart from 100, when we have number beyond 100, they get confused because instead of using money.
We talk about the methodology, the misconception that they make when they learn, when they're doing problems.
Decimal. We're dividing decimal.
What is wrong with this young man?
Yes. Sometimes in the answer they count the number of decimal places. Just like when we multiply, and instead of, for example, if you have 0.04 and 0.04 divided by 0.02, they would count, for the answer, they would count, yes, that's a misconception.
The answer will be 0.0002.
Yes, that's how they would answer it.
I've never seen this one though, I must admit.
I think another misconception too is putting it into the traditional form of teaching. So like when, for example, if you tell them 14 divided by 2, right? 14 divided by 2, instead of putting the 2 and then the bracket, not the bracket, but you know that, right? Instead of putting 2 at the front and right, what they would do, right? A lot of them do that.
I mean, even this is a very, very, very common.
The divide and the dividend of
Big problem. Huge problem.
Don't know the denominator and don't know the
The other one is just to discard the decimal point completely.
I've seen that one too. Just decide that if I have, let's say, just decide that it is this and give me that. Yes, I've seen that one too. Any other? No. All right. Now, what are the strategies we are bringing down? But how would we approach teaching division of decimals? I'm looking at Ricardo because I'm waiting for him now to tell me his coin, his money problem. That he, like, I think Ricardo is going to burst if he doesn't share his problem with us.
I think I understand what he's saying. It's like, okay, you know, you have 60 seconds in a minute, so you have 100 cents in a dollar. So many times you're thinking, okay, if you have 100 cents in a dollar, $2 divided by 100 cents, you know, how much divided by something cents, how much cents would that, $2, how much cents would that be? And they'll be like, oh, 200 cents, but when you tell them divide, oh boy, 117. They're saying, but we don't know about 117, we know about 100 because they started teaching them by using a dollar and saying a dollar has 100 cents.
But depending on how you, because
for example, if you're gonna teach a topic, they use money as a means to bring across decimal. I'm saying it will be a misconception because you have numbers beyond 100, like 1,000, 10,000, so forth. So once the students realize that they get like a larger number to divide by a multiply, they're going to get confused and they're not going to keep themselves because we will introduce them by 100. So they feel as if decimals are about 100 alone, but it goes beyond that. They also because page value extend to.
I see the point you're making, but I wouldn't call it a misconception. I would call it probably. I would use it to build, like that's one of the activities that I would use, but that can't be the only activity. So I would say that it might not be the most appropriate method or the only method.
Yeah. Not like misconception for them, but like the teacher's method of teaching it to them.
Yes, so probably the methodology that the teacher used might not be the most appropriate. You can use the dollars and the dollar idea, Ricardo, to start, but you have to go beyond that so they can see that. So nothing is wrong with starting there, but it doesn't mean that you stop there. You understand the point I'm making? So it's really not a misconception either, because the students have a wrong idea. It's just that if this is the only thing I'm doing with my class, it's not the most appropriate thing to do. Okay?
I probably something with what teaching might be.
Yeah. So you can expand the activity, extend the activity beyond that. Okay? But nothing is wrong with the activity itself. Because it can be the first one. Yes, so nothing is wrong with, in fact, that's one of the best places to start. Yeah, man. Money. Especially if it's a country that, well, in Jamaica we don't use cents so much. But especially if it's a country where they interact with dollars and cents, like, you know how US, they're spending this money every day. That's where that's easy to start. You can't say how much power is in a dollar. You know what I mean? You know, so that is something that you can start. Huh?
I'm saying how many $10 coins in $1,000 out here.
Yes, so that's a good place to start. For me, I believe it's a good place to start, but you don't end there. Because that's something that's a real life thing that most of them can relate to, depending on the culture, the context. Do you agree with me?
I agree. I mean, I agree with you.
You don't have to agree with me. That's
I would love this. I mean, if I can get you,
yeah. Okay. All right. Yes, guys. What are the methodologies that we came up with?
I would teach them to convert the decimals into fractions and work from there.
Yes, that's I think from person I believe that's the best method because fraction is a prerequisite. You know that they have been learning decimals fraction for a very long time. You notice that? But they're introduced to decimals later. So they understand the idea that really a decimal is really a special type of fraction. You understand that? So it's the same concept. Once a fraction is the same idea, the same concept. Decimal is really a special type of fraction. And what is special about it? Again?
Decimal.
What is special about decimal again? We did it last semester.
Denominator power.
All right. So it's a special type of fraction where the denominator is a power of 10. All right. So that's basically anything else? Do we have anything else? All right, so please take out your algebra tiles. We're going to look at factorization. How do we do factorization? And that's the next thing on the thing, factorization. So please take out your algebra tiles. Daniel? Yeah. Kasha is up here. Kasha is upstairs. Everybody else is you go. All right, do we have our fraction pieces? Sorry, our algebra tiles? we're going to attempt to factorize these things using our algebra test. What happened?
Good.
Yeah. Tell me.
I'm just trying to figure out how to do that.
All right, so I'm going to give you some time to try first, and then I'll give you a little hint if you can't, and then please don't research it.
Okay, what do you have on the board though? You have to read it out first, huh?
You can't see the board?
I can see it, but then some of the numbers, I'm not making them out.
All right, it's x squared plus x. The first one.
X squared plus x.
Yes.
Uh-huh.
Then the second question is 2x squared plus 7x plus 3. The next question is x squared plus 7x plus 12.
Thank you.
All right, so as soon as I want you to try and see what you can come up with, and then I'll give you a little hint to kind of guide you if you're not getting it right, okay?
No, it's like it. I like it. Plus 7x's, that's too many x's. Yes.
Oh, that's
why are you giving us so many x's? We draw them.
You don't have enough x's? Oh, I'm sorry.
I think
myself.
How many x's? Yeah, because when we finish one, we can go to the other one.
Yes, you do one first. I said that's the one and then draw it so you can remember it. Okay, guys, when you finish one, you can draw it. And then you move on to 2, then you probably draw it. And then 3, draw it, and see what happens.
What is what you mean? I should not know it. What did he?
You can't know the answer. Just go down. Oh, you worked out first. That's the thing.
This is fun. I think I've got it.
No, how did you go to get it?
It's cheating.
You're cheating. Think about what factorization. You're looking for work.
I'm not sure. Look, it's a square, right?
I'm not telling you. More everything. Just like the way it's in the things that
Sorry, one of the many of these ones are in. There are no ones in it. Yes, but they're not the same size. They're not the same size. Alright, so how many of these? No, they're not the same size. X squared x multiplied by x. No, it's
so I think about the measurement. What is this measurement here? This is x squared, so we have to think to it. This is x squared. What is that here? So x. And this is 1. X. So when like this distance is 1. X. And what you're doing here with 1. Good, that's why it's the 1 by 1. So that should help you. Finish working, guys? Zana, finish?
I'm still working, and you're here. I'm still working.
And you're still working. Zana, are you finished?
Oh, no.
I've done the first one, though.
Okay, you finished your first one. Good. Carlene, are you there? You have to have your kit. I'm gonna tell you the other things that you need for your kit. But you have to have your kit. Do you have your kit? Sabina, are you there?
Yes, I do have my.
Are you working? Diana, are you working? Diana, are you working?
Yes, I am.
All right, Jeffo, are you working?
Yes, yes, I am.
All right, so I'll give you 5 more minutes, and let me see what one is going to doing, and then 5 more minutes, and I'll give you a little hint, okay? Just think about the measurements of what you have there and what you can deduce from it. All right?
You're stealing. You are writing.
Good job, Ingrid.
Very much.
See, yeah.
You finished number 1, no?
That's what I'm going
See? And then X square, and then you multiply X file. This is X squared. Remember the thing with the area concept?
Ah, good job.
That's what I was thinking. But to get this, X file. To get this, X file 1. And this is so this is what we're given. It's all right. This is what we're given here. I'm just using these because I know to multiply to something together.
And then just match it.
You know, I did it before and then I couldn't figure out what was going on.
Just match it. What can match it? So just figure out the size.
I'm just trying to
see. You have this. So what? You say you have this. See it on length and we can select.
Yeah, so that's nice. We'll start with 2x squared. 2x squared plus 1.
Okay, so
We need so much ones.
I am taking out 3 ones, Dina. It's plus 3. Where did I get 7 from?
You got some x.
Some x's. What's an x then? Plus
And then over here, so.
Yeah, I'm going to give you this. Right.
What do you do?
Class.
Oh, cute.
This was made out candle.
All right, guys. So what you're going to do, the idea is when you're factorizing, you're making rectangles and you're figuring out the length and the width will be the factors. Are we following that? That's the end. You're creating a rectangle for all these questions. So you're going to use the x squared and the x to form a rectangle. Once you form a rectangle, you now need to figure out what the length would be and what the width would be. That will give you the answer. Are we clear? And let's. All right. Let's look at this, everybody. Just to ensure that we're clear. Now, if this is x squared, what is this distance here? Somebody?
X.
X. And this distance must be what?
X.
X. That's the only way this can be x squared. This distance must be x, and this distance must be x. Are we clear? Now, let's look at this one now. This is what? X. Is it the same distance? You know, it's the same distance as the square. So this side is what? What is this distance here?
X.
Good. And what is this distance here? What do you think? It compares to this.
1.
And this is a 1 by 1. So what you're doing is forming a rectangle, and then you're matching. Then so after this is a rectangle. Okay, is this a rectangle? I'm using my x squared and my x, and I have a rectangle. Now, if this is my rectangle, this is a what? What can match here? So this is a what? X. So X can match here. What would fit here? A 1. What can fit here?
X.
So my answer is X times
X plus 1.
All right, so you're going to form the rectangle with these. And then once you have the rectangles formed, then you can figure out the length and the width. Is it clear? Good, try that.
Yes, very clear.
You know what's the length of it? Okay, what's the length of it say? This is how much? Yes, the length of the side. Yes. Okay, so so I must find out the length of the side. Oh, the side. So what it said, the rectangle. What's the length of it? No, count with the x's. No,
1, 2, 3, 4.
So this is 1, 2x plus 1, and x plus 3. That's one.
Another one up here.
What is the x and
Another one.
And this is the one that was here. So notice. No. It says that x is 1, it's 2x. And the portrait one is 1.
So this side is x plus 3.
That's
x plus 3.
Check it.
This side is going to be off the net. This side is x plus 1.
Alright,
You can figure this out.
what do you mean? You just tell them to make a rectangle. Tell them to make a rectangle, that's the length.
Okay. But that means we have to introduce them to that.
Yeah, so, because there are others, and you're going to do more challenging, the challenge them not to think about it. But you'll give them to say, all right, say, like for me, no, I'm expecting to deduce that your size experience is X. I'm expecting to deduce that. I'm expecting to deduce that this distance is X and this is that. So the instruction I just gave you, like what I went on and showed them, going through what these things mean and the distance is. Then now, I'm performing tables and figure out what are the lengths and the width. So then, you know what I can
Well, yeah, if they understand.
If you have to give them accuracies.
Some of them will do it without it still.
Yeah, some of them, the ones who can tactile, who can do that.
It's hard.
So this is x plus 3 divided by 12.
You just want to form a rectangle. Try to form a rectangle. Figure it out. No, there's not a system of it. You just know that you form a rectangle. So all you do, you fix it now. Because you fix it some of the way you want a rectangle, you just want the measure six of the rectangle.
I'm not trying it. So divided by next one. I'm going to go down the x plus 1. In the x plus 3.
I'm going to add another one.
X squared.
Add more of that on it.
Let's put in one more.
You got the right one answer?
Yes.
You got the answer.
Because
Okay, this make the next one. Yeah.
Language.
X squared,
X
2x and a 1.
7x.
It's not much
Sorry. You know what happened? No, I know. I just went to the last one. The last one. No, I always do the last one. We had the last one. So I just went to the last one. X squared plus 7x. I won't work. This one is not the same. Hold on, how come your X are short? That X is the wrong way.
I think that's Some of them are flawed, like in terms of the measurements. But, just 12. Yes.
I'm giving just like the children. 7 plus 12.
Yes.
Help is needed. I think we're gonna have to put some across the top.
That's what I
think we should move it. Put them up here. There's no way you get 12 otherwise. Oh wait, 1, 2, 3, 4, and then yes, 3 times 4.
Ah, you gotta learn it. Yes,
this one is sick. Go away.
Yeah, but guess what's going to happen? Is that what I'm talking about? This tactile learners, you know, what I'm going to do? Let's go to drawings.
I think I'm going to use it to draw.
Yeah. That's what I'm saying. They're gonna, sometimes they literally move it like, they just draw it, but then it's a factor of drawings.
Okay, instead of doing
because if I don't remember factorization is actually steps, they multiply the A by the C.
I never learned it that way. The first time I learned it, then I started to teach.
How you learned it?
How you learned it? Simply that the factors of the first term and the last term.
Oh yeah,
and trial
and error, yeah.
Yeah, but
and some
the trial and error takes
time.
And then the students were not that smart.
Yeah, they will figure it out.
So it's like so that's too. It's very algorithm and they don't remember the algorithm, so they're in trouble. But if they can draw it, they know that they know, okay, what I'm trying to do is a comma. And rectangle.
So X plus 3 and X plus 4.
Good job. Good. So the answer is what?
X plus 1, X plus 1.
And X plus 1.
Oh yeah.
Are we finished? Are we finished now? Still having time? Anna, you're finished, right?
Yes, I am.
Donna, you're done?
I'm just done with the first one.
You just finished the first one? Do you understand what to do though?
No, you did the first one already. The second one. Yes, I got it now.
Okay, so
as you explained, I understood it.
I'll give you 5 more minutes to go through the others because I really want to do them so that you can, practice.
Okay.
Okay. All right, so I'll give you some more time, okay? Diane, are you finished? Diane, are you there? Carlene, are you finished?
I'm here.
I'm not finished.
All right, do you understand what to do? Carlene, do you understand what to do?
I'm trying to figure it out.
Okay, so were you here when I was explaining it?
Yes, I was.
All right, so you want me to explain again?
Yeah, that would be good, thanks.
Okay, I would like you to explain again. I'm not really sure.
So go ahead and draw them so you can remember them because I really wanted to put them on the I told you, you just weren't listening. All right. So as I was explaining, so I'm going to do the first one with you. As I was explaining, for this to be x squared, okay, it would suggest that this distance here is x and this distance is x because x times x, that's the only way. So this is really a square. So literally x times x gives you the x squared. Agree? So I'm going to go again. This distance here is x and here is 1. So if I multiply, because this is a rectangle, so it's an x times 1 that gives me the x. And this is a 1 by 1 square. 1 times 1 is 1. If I now need to represent x squared plus x, my objective is to form a rectangle. Once I form a rectangle, all I need to figure out now is the length of my rectangle and the width of my rectangle. So this is my x square, and I put it together. I put it together with my, Dina, this one is, excuse me. And I put it together with my x. As you can see here, I have a rectangle. Do you see that?
Yeah.
Now, if this is a rectangle, I need to figure out here, this is my length, and this is my width. Agree? This is my length, this is my width. Now, what would you say the distance, because of what you know, what would you say this distance is? This is a what? What is this distance here again? That's the first thing I told you. Come on, guys.
X.
And what is this?
1.
1. So this is x plus 1. What is this distance here?
X.
X. So when we move on to, so my answer would be x times x plus 1. So when I move on to 2, I need to take out 2 of the x squares, I need to take out 7 of the x, and I need to take out 3 units. Once I take out all of those things, I now need to line them up properly to form a rectangle. So by trial and error, I'm going to line them up properly to form a rectangle. Once I have what looks like a perfect rectangle, then all I need to do is to figure out my length and my width. Okay? So that's what factorization is about, really forming a rectangle. Are we clear? So try it now. Give us some more time to try it, okay? Is it any clearer, Caroline?
Yes, it is.
All right,
Thanks.
I'll give you some time to try it now. No, it doesn't matter now. It's because of this. This. I think what England is trying to say is if they can't go anywhere now, but if you put it in this, they don't know the command, it won't give you a rectangle. That's what I'm saying? The island was have a rectangle. Yeah.
If you want to be better longer than the X.
I mean, some of these trips are manipulated.
That's one thing and it's very difficult to understand. But then it's smart enough.
And then some of them more than me. No matter where this one
This is my worst
exposing them, so when they don't remember to multiply them, because nothing literally, if they don't, and the person literally don't remember, I don't multiply, and you find, because it's a memory thing, you know, because I'm just telling us, oh, you multiply this by this, and you get 6, and then you need 2 factors of 6 that give you whatever, and you go try to expand the middle term, and blah, blah. This is very unbelievable. Now, if they don't remember the step come first, that's it. They don't remember what to do, that's it. But if they remember, oh, well, it's going to be dry. Yeah. And they will go with their cross range. That's an it. I'm surprised.
We have to show the steps to the change.
Exactly. And even when because they want to have a rectangle, they get the answer. Even when I was doing I was doing turns, and I have the students draw parties up and the turns I want to go. You know, once let's very people says I saw them drawing the turn, like I mean that's what yeah. The ones where something really. So even if you have a small group,
So first thing you say this, it's that it's usually work well, but you can get into one.
Okay.
Take care of the
So,
No,
just to even just that let me say how to start introducing this people can actually start the activity. And so you know we're gonna do so and so. So they kind of take a look at time and ease them into it. And they will see just how challenging it is. Like, you know, take a look at time and ease them into it, man. Ease them into it. So you don't treat them like all right, we're gonna learn how to use this to do this, right? It's a big new exciting thing.
really much they can explain. What have you done? What have you done? What are you? Okay, well then I'm going to make money. We didn't find an answer. We're doing X plus 1. X plus 3.
No, you don't need these. This is what I'm doing.
That's so much fun. And then that's not right. That's the right time. Right. What's that? Oh, it's over here. All right, we'll have it today because you realize you didn't do it with us. Okay, so it's like
no, this is length. Look at it. This length. This is X. And what is this distance here? What is this distance here? And what is the distance? That's it.
Oh, so you increase X here?
No, you're just looking at the length and the width. So the same question here, you're looking at this distance and that distance. Or you can have this the same difference.
You find in the length of the sides.
Yeah, so if I go like.
It doesn't matter what this direction we're going to be the same thing. Look at it. What is the distance here? What is the distance here? So that's the one length. What's the width here? This is one. This is that.
Okay.
One.
Okay, so these are because earlier when you do analysis, so
you can put things there now for the whole
like X plus. You know when we do before. When I do it around 4, we never go to stand on X plus 4.
Yeah.
And then we go up and say X plus 2. That's what I'm saying because that means X.
What is X? This X.
Because the distance, you know this distance. We might just start with this distance X, that distance X. This is X, that is more.
So this can
I even go started. I did the first one on this song.
You did? Where?
Not like physically did it. So go started number 2.
Oh, yes.
I finished working. Ingrid is coming to do number 2. So by using diagrams, using diagrams, she's coming to do number 2.
This is one of the 7 X. You want my new way?
No, I want to do it myself.
Okay. Is this one you do a while ago? Thank you. No, seriously, is this one you do a while ago? Yes, no. Oh, yes.
I know it's not that. Wait, it doesn't matter seriously. Let me see if I can get my opinion. How much is it?
Oh, the one that's on there somewhere?
Where here?
No, the bottom.
On here?
Just one more.
How much did you Loading and this won't work. That won't work. Loading, I won't work. I don't know what we did. I don't know. No, that's what we did. I'm trying to remember what I did.
What is the external distance? What's the distance? Is that a rectangle? Okay. This distance here, this measurement, and that distance here. This distance here is not x squared, so there's x. This is right. You know that this is is that able to be you have x squared plus 3x.
This is the one?
Make another question.
Okay, here we go.
Is a distance.
So we have x squared, 2x squared, and we have 7x, 1, 2, 3, 4, 5, 6, 7, plus 3, 1, 2, 3. And that forms a rectangle.
Are we paying attention to what she's doing? I think so. Can you see the board?
Yes.
Yes, we can.
So what she did? Okay, so what she did, she drew it on the board. Okay? So this distance, I'm going to give another color to this distance.
So we have 2x squared, 7 x's, and 3, forming a rectangle. So this distance here is x, this is x, and this is 1. So from here to here is 2x plus 1. And this distance from here to there is x plus 1, 2, 3. So it means that my 2x squared plus 7x plus 3 is the same thing as 2x plus 1 multiplied by x plus 3. Everybody got that? Everybody's following?
Yes, we got that.
Okay. Any questions? Okay. You can use yours. Use any way you want.
Once it forms a rectangle, they just need to figure it out. Good. Carefully. Huh?
Should I erase? Hello, guys.
All right, so Ingrid is doing, Dina is doing question 3, and okay, I just having them draw it because you guys are not here to draw it for me. I just want to be, so please check yours to see if it is correct, okay? All right, guys? I'm not hearing you.
Yes, we are.
Yes.
Did you get number 2 correct?
Yes.
I did.
Yes.
Correct. I didn't get number 2. It was difficult for me to line it up. I was not getting the rectangle. I'm wondering, you have taught it before. I guess you have done this with your students. How easy it is for the student to come up with
The rectangle?
Is it easy for them?
But to come up with a rectangle, look here. Yes. Trust me, the students come up with a rectangle faster than me and you. Because it's I think it has to do with spatial awareness, just understanding how to fit the things. So what you need is just a perfect rectangle. Once you have a perfect rectangle, if I instruct them to form a rectangle, be creative and form a rectangle, they'll form it faster than me and you, for sure.
Okay, but what I want to know though is in an exam, especially for maths purposes, would that be allowed? Especially when you look at CXC, would they allow if the child, let's say for example, comes up with that algebra and draws it up and gives her and the answer is correct? Do they want to give the child a full marks for it?
Full marks. full marks because we're not pinning it full marks. We're not, because yesterday the process are very, the point I was making earlier to the Mona students, because I'm working along with them, showing them the tasks, I'm able to explain while I'm working along with them. When you have a child who, you know that algorithm where you multiply the 2 by the 6, 2 by the 3 and get 6, and you got factors of 6, and you expand the middle term and blah, blah, blah. The students, when they can't remember the different steps, one come first, one come second, they just leave it out and they never do it. But the ones who are tactile and they remember that it is all factorization is about, is forming a rectangle and determining the length and the width, they just draw it. Once they draw it, they're perfectly correct and able to write down the answer, they're perfectly correct. And most students will remember that factorization is just about forming a rectangle. All right.
I actually do appreciate that method because I'm sitting on here, I'm saying, but here's the situation, I don't have to, all the algorithms involved. Another student, the students can just put the rectangle together, get the length and the width, and then that's the answer right away. To me, I see that as being a more simple and more understanding method to getting the concept of factorization.
Yes, and I think so too, but you can also expose them to the algorithm, you know what I mean? Still, you know, but your choice. You can. I would still expose them to it, but yeah. I go there.
Excuse me.
Yes.
You don't have any with negative numbers, no?
Yes, we're going to look at one right after we're done.
Okay, all right.
Hello again, guys. So for number 3, we have 1x square block. 1x square block, right? And I have here x, adding 3 x's. Right? In 7 x's, so x's, and you need 12 units of 1, right? 12 ones. So 1, 2, 3, 4. Right? So basically, you have your rectangle, so you have length times width, right? You're getting the area here. Right. That is x plus 4. This side here, just erase the questions that are done already. Sorry, miss. And you have here x plus 3. And that's the length and that's the width. You know, length times width. The area, x plus 3, x plus 4. And that's your answer.
All right, so one more, and then I'm going to put some -1 on the board. It requires a little bit more, but with, yes. Huh? That should be fun. Come on. Go for it. No, come, you come into the last one. It takes a little bit more, having the students, a little bit more thinking in terms of figuring out what should go where.
Okay, we have x squared plus 2x plus 1. X squared. So the length of this side will be x plus 1. Here will be x plus 1.
Are good? Very good.
Answer properly.
Substitute the negative 1. X squared plus 2x minus 8, that's 1. 2. 2x squared minus 7x plus 5. Alright, try that for me, please. Just take it through a little bit.
What's it? Minus 3x plus 6?
No. X squared plus 2x minus 8, that's the first one. The next one is 2x squared minus 7x plus 5.
Okay, thanks.
That's 2x squared. No, x squared plus 2x minus 8.
It's factorable. So that's the difference, for example.
It's cheap. This is minus x plus something. Do something properly.
That's not the right number.
Okay.
You don't have 8 of them?
It's not that. 8.
You don't have 8 units?
8, you don't have 8 units. Not 8, not that type of 8.
What are you doing? Formula rectangle.
X squared plus 2x. Okay, what is your
You need plus x squared plus 2x minus 8. So you need the red ones.
red ones? 8.
So the formula rectangle.
Oh, let us make these into 8s.
What? Is that rectangle? Is it rectangle yourself? It's rectangle yourself. You have to match.
Number 1 of x. I'm going to have to find another way to make the
What about putting them down here? Because it can't. This looks like a. It's supposed to work. It's supposed to work. It's supposed to work. It's what? Count the one. One count is okay. The count of one. It's the sensor stands. We don't know what to say. Alright, so probably I need to try to make this like that. It's not terrible. It's not terrible. I started with it. Clear it and see. No one is hot to me. Great. Definitely X match with X. So everything. Get another sound move. No. I'm not hearing anything. But we should, that's what I'm saying. And you understand why not? This is 2x. We're factoring. And says x squared school. What is 2x?
It's 4 pounds.
Okay, let's line up the minus. Let's just line up some minus. You want to get some zero or something. Let's see. It means I'm going to have to play for minus. Miss Getty, I'm not here. So this is no negative x here. X is minus 3. And why x there? Why? We're just trying to get 2x and then 4.
I already told you how to do something.
4, please.
Oh, I see. I see. You can get too excited other way.
Yeah.
Yes, because I have it here. Because if I put 2 of the negative here, if I put in 4 negative, if I put 4 of the other here, 4 negative here, I'll do 2x.
Okay.
So it's still going to end up with 2x, it's just that you have to form what the 0 here to form its always. Yes. Yes. So these two become 0, 6, and 2x. And it's the first time we pick up on one hand. Yeah. And you put in the 8 now?
No,
Why?
X
Oh, X plus 4.
2 and then X.
But the X is negative.
No, that's the thing. No. This is the thing. No. You have to start thinking. What is it that gives you an X squared? Is the negative. That's how you figure out what should go there. So
it should be the black ones here?
No, it's not a one. You only need to figure out what should go here. Is it that what I want multiplying with you this? So that's
so what I want
that's how you
to get that.
So that's how you figure out.
So it would have been X. You can have X, negative X and negative X, you're going to get X squared.
Oh, okay.
So X squared times X squared. So negative X times negative X, you get X times X.
Because you have an X squared. So what give you X squared? Well, it's an X squared that you have in what give you X squared? It's negative X. So you have to think about it.
Yeah, it's not really switching, but it's just.
It doesn't make a difference.
I need to what's the X squared?
No, you don't have to. That's the thing. You have to think. So the negative, you have to think. What is this I need to give me this N1? Because it's a rectangle, you know, so it's like a multiplying. What is that I need? So you think about what you need. No. It doesn't matter. So, let me do it one time. Just form a character.
Okay.
That's what you're learning about them.
It's too much.
And so if you look at the length and the width, right? This is like X. Okay? So 1, 2, 3, 4.
That's X plus 4.
Alright, what is this?
X minus 2. And that's the answer. If I went on this side,
But that's the thing, you have to think what
negative X minus 4.
Because if I have negative X on this, I will get a negative. So this is going to be a negative. This one is yours is going to be a negative.
Oh, it could be, you know.
Could be.
Yeah, it could be. I think you could write it. You went this way and this way. You write it the way that we just said. You went this way and this way. You have X minus 4. It's a negative X minus 4.
Okay, that's what it's saying. But what they do is they think of what you multiply by to get an X squared.
Okay.
I don't know, maybe this one is have to figure out. I rather think it's another way. Never. Alright. You have to figure it out another way. Alright, so can we do number 2 to the drawing for me quickly? I call it share the red one. Alright, so we're having hiccups, but we're working through them. It's fine, it's the same problem. You understand this the whole basis, it's still the same question.
Cancel that.
I'm just trying to get the process negatives on this side. I don't like them.
Or like you should use one side and the other side. Well, you know, minus sign now is neutral. That's why I'm going to get the look and teach me over and ask me. This is what you understand.
But what we normally do is think about what gives you the X squared. This is a negative that will give you what?
And then you say,
no, it's what gives you the X squared. You know, this is the X squared. What gives you an X squared? You must get X times an X. So that's what we know. So they have to put a little bit more thinking into it.
I have to do that instead.
Today, you're going to make different. All right, try number 2. Click the joint and try number 2. Finish? No, you remember the other thing. Take it through. What is next? Really? No, you don't have to. You can think what makes it. But like, how do you figure out?
What's the mean students in here? So then just
Two X minus 3.
This is not yours, you know? We do them over there, you sure? So we get them.
We're going to calculate.
You're stealing things, young man? It's better.
But this is 6.
Oh, one more student.
Oh, they're really the same. What's the question?
What you have 6 minus 1 is right.
No. You can make a rectangle. You should have told me. It's a rectangle. You should have said.
Yes. Where was your rectangle? It wasn't 5. 0 is going to be 0.
In the part of
5.
It's very. It's the other part.
Brilliant. Brilliant. It's smart. It's brilliant.
Yes, but I think
It's 2 X's in probably.
it's
Or 1 X.
there.
It's 2X squared.
It's 2x squared.
Yes.
Oh.
It's so much work.
1, 2, 3, 4, 5, 6, 7, 8. What's that? 1, 2, 3, 4, 5, 6, 7, 8. See, how the gates are there, man? 7. Can you have them different colors? 1, 2, 3, 4. Three. So 5 plus 1. 6 on the other.
This is high.
How do you make it? No, wait, I'm going to resort to filling it. Go ahead, I want.
We get 5.
So that 1, 2, 3, 4.
This 4.
4. Okay, no. Much more? 5?
First one is again, yeah.
No, it's 5. Is that comparable?
Doesn't see that.
2 times 5 is 10. Factors of 10. Makes it 4 next to that.
I'm going to have an X plus 3 on X plus 4. Or I will put it 5.
It is factor. You don't see it?
What's that?
2 and 7.
2 and 5.
No, the factors. And just a more room for it.
Oh! The factors are x minus 5 and x minus 1. No.
That's not working for you. X minus 5.
Because it's not 154, it has some sure.
X minus 5.
Yes, if we can do it model.
And what?
You know what I just think? I said 2 times 5 is 15.
And X what? X what?
I'm cheating, not you.
Minus.
Here we go. I'm cheating very well. What's that?
Yeah.
No, I'm getting an answer. There it is. I'm cheating. But it's cheating at work.
That's the negative.
Yes, it is. What you cheating was again?
Oh, it's because we have a problem making the rectangle. Making the rectangle pretty soon. Oh my gosh. That is the students almost, especially over here.
Oh, that's right. That is a negative. So we don't make it up?
What's the X minus 1?
What are you talking about? The X minus 1 here. That is the one that your sister is supposed to do.
Oh, what's I mean?
To read it. Because I was reading it up here by 1 minus 6.
Oh, the character is very English.
Mm-hmm.
No, because you need
If
to
I read
remember
it this way, I
it.
get it perfectly. But if I do it this way, I get the negative.
But you need an x squared, or can you get an x squared? But you have to think of that. How can I get a negative 7x? How can I? So that is the part of the thinking that is missing. But when it comes to the negative, once upon the rectangle, you pick up. You know, it's the x squared. How do I get x to x squared? You know what that is? It can't be. So you still have to you have to multiply in your head for the negative. That's the yes. That's the shortfall of the negative. You have to multiply in your head. She found it from the rectangle.
You go back to it.
She found it from the rectangle. I want to say from the rectangle.
Maybe I think so. There's some, especially those who are Latin. I use the answer.
I drew. Still working?
I use the answer.
Still working?
Second one. I got the second one. But still working on the first one.
I got the first one and thinking twice about the second one.
Do you have to make that square for that one?
Yeah. Say the square, what is needed to complete? That's a concept, complete the square. So you have x squared plus 6x. Blank. You try to form a square, take out the front of the conquer, what is missing? You understand what I'm saying? Yeah. So it's really forming a square. Maybe it was a long time to make this rectangle.
No, I didn't think of it wrong. I think that's why.
It's trial and error.
But somebody said that's probably what it was.
Students might get blinded. It's so simple, and then you're like,
we're visual learners. I think that's very tactile, especially when we are very know what to do. So even if time graph means it's a very long time to get. So
so that's why because 8 years old, I And they tell you, you can come, you teach him how to minus
Alright, so
that number.
you're not gonna draw his finger.
The child just said, because take the stones and start minus. I didn't know if you think of it.
The stones?
The stones, like 80 stones.
That's my dad.
When I'm going to take out
That's what they're
25 stones from.
That's what they're doing. Anything I'm sure.
So this one, this is actually a positive x squared. This is a positive x squared. Yeah, and then minus x. So this one is really positive.
No, if you have x squared, think about it. If you have x squared, 2x squared, is it that you have two negatives instead of that, or two positives? Agree?
Yeah.
So if you see a negative and a positive, something is what? Wrong. So it's just the awareness that once you have, say,
But you have one over here like that.
no, for you to get 2x squared, you need only positives. So that's you have to focus, and that's the only way you get the only time you get the x and have the x squared. Think about that. So there's a strategy to it. So if I need this is a negative 7x now, how can I get negative 7x? How possibly can I get negative 7x? Okay, so you must have a positive and a negative.
There's not how you read about it. That's not really important.
No.
As long as you have the right number of pieces.
As long as you're multiplying, you have to be multiplying in your head. That's the situation. So you have to, when the negative, you have to, with the positive, it's just easy. But once you work with negative, you have to be working with negative.
It's the only one.
Yeah, but it can't have a negative and positive, so that's not a question.
In this page,
With the units of 0.
so you've got 7.
Oh, what are you doing?
You cancel out, you've got some 0 pairs. You have to have 4 exits and negative 5x. You've got, it's not a positive side, you've got negative 1. Because you got 1, 2, 3, 4.
I'll finish now. Alright, Dana, do you want to draw while Sana explaining? Alright, Dana, Anya, you got number 1? See what they have. Sure. Anya?
Yes, I did.
Alright, do you want to share it with us?
Okay, sure. So let me just rearrange it back because I was looking at number 2. So
Okay.
okay, so 1x squared plus 2x.
X squared. I'm following her, right? I'm listening.
Just let me just rearrange it back because I was working on number 2.
Okay.
Okay, I think I'm ready. So on the right, you draw, hello?
Yes, I'm listening.
Okay, 2x, 2 of the x blocks on the right, on the...
Right hand side, yeah.
Okay, yes, that's what I'm saying, okay.
Okay.
And we need 8 red ones, so we have to fit them in a rectangle, but there will be empty spaces. So what you're gonna do, you're gonna use 0 pairs with the X to complete the rectangle.
Okay.
So next to that, we'll have 2 more X's, 2 more X blocks.
Okay. 2 more X blocks.
Underneath the X squared, you'll have 2 red X's. So that would be our 2 0 pairs.
Right.
And then we put our 8 singles, red singles, next to the 2 red X boxes. So that the 2 bottom rows will be our negative and the top will be positive. So we end up with X plus 4 times X minus 2. So across is, if you on the top, X plus 4. And on the left is X minus 2. I don't know if that's right.
X minus 2. Yes, correct.
Okay, good.
Oh, you know, try it. It's really not pink. It's not really, it's really it's how many of the X and how many of the
Yeah, but you can't even if you think about it.
Yeah, you have to think
about
about it.
Alright. Okay, Jeffer, come draw the other one, or somebody else come draw. Jeffer?
Yes.
What's your number?
Yes, I'm here. Yes.
Very good.
You need 2x squared going across. And to the right of them, you need to have 5 long x's. So, yes, the x's. 5 of them, 5 red ones, that is. You can probably
Okay.
to the bottom of the 2x squares, you have to put 1 long red one going across, right? Another one under the other one there, the other x squared, and 5 single units under the 5 long red x's you have there. And going across, you'd see you have 2 x's minus 5. 2x minus 5. Yes. And going down, you would have x minus 1.
Okay. Why did you use the side?
Why did I use the side?
Yes.
The bottom.
Why?
To make it fit. To make it fit.
Why? Because this is negative 2x, right?
Yeah.
And this is a positive 5.
Mm-hmm.
So why did you use this?
Why didn't I use the positive? Why didn't I use the positive? Because my answer, since the quadratic expression there has a negative 7, that means my answer must have negative somewhere in it. And at the ending, the 5 is a positive.
Go again.
So,
Go again.
At the since my quadratic expression has a negative 7x, that means there must be a negative somewhere in my answer. And because the last term in the expression is positive 5, it means that there must be a negative times a negative to give me a positive. So if I had used it the other way around, I might not get I might not have gotten positive 5 at the end.
Okay, that's it. When it comes down to the negative, you have to think, you have to really have an idea of what your answer will look like. That's it. Huh? You do.
That's what I was thinking.
Negative x
plus 1.
Yes, probably still work this way because now the opposite. But really, when they go to exam, that is the positive version they're looking for, not the negative version. But what you can even answer to do is write both of them. Or you can test the answer too, like quickly multiply it and test it back.
But if they do it,
no, I'm saying they can do this.
Yeah. But if they get the negative though, I mean, that's still correct, right?
Yes, it's still correct. It's still correct, you know, but you know how.
No, I was just wondering, would that get
traditionally
for exams? I mean, would they really matter correct if they get that concept right?
They will make no attention. They will mark them number. I think because the whole concept, anyway you go, you're supposed to get the same.
Yeah, but what I'm saying is that's the same answer.
So remove the bracket. I don't know. But
I have a question.
Yes, I think
my question is, what if instead of plus 5 we had minus 5? How does that change the answer?
What if instead of what?
Instead of plus 5, we had minus 5. Based on the arrangement you have on the board, that wouldn't change our answer, would it? And our answer does change when you factor.
What we used to make a rectangle, the thing that we use must be something that is factorable. If that's a word.
So we have blue, negative 1. You'll be raising negative 1.
If you're saying this should be negative 5, then this is not factor. Like I can't factorize.
No, it's not that. I was just saying with the tiles, the arrangement of the tiles.
That's what I'm saying.
I don't understand.
Like if the student has to use this, I don't know if you understand what I'm saying. The student has to use that. Right, but I'm saying if this, you know what? Never mind.
Yes, say it because I'm not following you. Could you say it again for me, please?
No, it's fine. It's fine.
Please, we want to hear because
something I want to know though. There's Anna here. When you're looking at the length and the width, do you take it in any particular order, or any particular side, or are they supposed to correspond in terms of the answers?
No, well, I don't know.
Because if you observe what's happening here is that if you look at the width at the top, it reads 2x minus 5.
This means, yeah, but the idea.
This here.
So
that's why. Because what if the child decides to take the bottom length, which reads negative 2x plus 5, and we know that negative 2x plus 5 is not the same as.
But that's the thing she was explaining now. When it comes down to negative, you have to have something in your head as, okay, if I have here, this is positive. How can I get positive? Is it a 2 negatives that will give it that positive, or 2 positives? So you have to think when it comes down to the negative.
I observed that.
Yes, when it comes to negative, it requires a little bit more thinking. You have to have a reasonable idea in your head that for me to get positive, this is positive, but this 2x squared to be positive, I'm either going to have 2 negative or what? 2 positive. So that's the trick there. You have to think when it comes down to the negative. How can I get this? But you have to think there when it comes down to the negative.
I don't think they should have the standard way of getting it. So I think if they have like negative 2x plus 5 or negative times negative x plus 1,
no, you could use the what if
They should give them a card.
Yeah, but she's saying that this distance and this distance, they're not the same.
Oh no, I agree with I understood what she was saying. I just mean like in exams, if they get it the other way, if they put negative, they should give it x plus 5 times negative x plus 1. I don't think they should get
because it's still because when I work it out, it's still it's a factor. And in fact, the thing I want to it's how we're training. It's really how we're trained.
Yeah, we should be
because if you look at 6, 2 and -2 and -3, those are factors of 6 and 2 times 3. But our culture is that we tend to take the positives. So you guys might be onto something. Our culture is that we take, okay, if I ask for factors of 6, I'm not expecting you to give me negative. I'm not expecting -2 and -3. But truthfully, they are yes. We're really expecting 2 times 3. So probably that is how. Yes, because I remember when they.
But the AC method, they have to do that.
Because I realized this when the persons from Singapore came and they were doing when they're doing these things that they have alternate answer, they realize that there are several factors, there are several answers, there are several possibilities. Yeah, there's several possibilities, but we are just looking for positive, and that's all the whole discussion about whether -2 is a even number. That's how the discussion came about because our culture tends to take the positive version. So I don't know. So you guys might be onto something interesting. This was interesting. I've never done this one before. Never gotten that because I usually give the student a question, but I've never. No, not that one. The one that you have to fill in. I've never did.
There's a filling one.
This is it?
Yeah.
Okay, this one. Never. Yeah, I've never done that one before. But all right, so I wanted us to go into. I'm sorry, I think I one question. I don't think I have a lot of questions. We'll pick up yours next class. All right. I'll just give you one question. Probably you can go home and practice with this one. Yes.
Read what's on the board, please.
All right. So we're moving away from factorization and we're going into completing the squares. So I have x squared plus 6x plus. What do we need to complete that square? So it's a literal square that we're making. So you're going to use this thing to form a literal square.
She's just instantly like everything. Should we have other side? Usually other side. I must make a square. I must make a square. Okay, this square means make a square.
And give me the answer. You're going to give me the answer. All right. So I'm going to write equal.
You got a name?
And your answer is going to be x plus dash all square. Yes. Square, that's all. Square.
You know this is one x? Yes. No one that got this.
X, you have X, you need 6X in the form of square.
Oh my God, I just square. That's a square unit.
Because this is what? 3X plus 3. So how much is it?
1, 2, 3, 5, 3, 9. What do you want me to tell you that to go about finish up and then I don't put in some kind of thought or something. Also, you know, I said X plus 3, X plus 3. So this is what I know. Take a picture of it. I'm serious. Oh, and the people don't I can't remember actually months ago. You can't use them. Anyone?
No, I have something I need to go through the. Let's pick up here because I need to do different between two squares. I'm using paper instead.
Where's it at?
No, because it's a difference. One difference between two squares. So we're going to put it. Alright, so why if you have x squared minus 1, the answer is x plus 1 is minus 1. So you establish the proof, and then so you can know that once you say no man, just showing up the factorize x squared, and that's what I want to do, but enough time before I need to do the x squared. But enough time was in there. So why is it like
Miss McArthy?
Yeah.
I think I have the answer.
You think you have the answer? Okay, let's give the others 2 more minutes, okay? Good. I have to look at one more thing. Because then it's a perfect it's a square. So what's perfect square? Let's say x squared plus 4x plus 4. Yeah. X squared plus 4x plus 4. That's a perfect square. It's x plus 2x plus 2. So I could give you. So you can give you this. X squared plus 4x. So what number is missing there to complete the square? Then I might give you what is missing there. Remember completing the squares? You know completing the squares? It's a remember this is where you start. So you're completing the square, you know. But you know that thing that you do for the parabola, the roots. You know what I'm saying, sir? No. Okay. Yes, so then what is it that makes? So this is x plus 2, x plus 2. So what is it that completes it? That's why it calls completing the square. Okay. Yes. So you know because students will not see after this, they have to fill it out to see what complete. Huh? So yes, so some say this is the part where sometimes they give you a number at the end. You know, so that's the one we record a number at the end. So it's a translation from this into that. This is the first part. Do you understand me? No, I'm not understanding. Okay. Sorry. All right, yes. Jennifer.
Okay. I started with the x squared in the.
I'm gonna allow someone to draw.
Okay.
Come. Somebody come and draw quickly so that we can see. We need more time for this.
I started with the x squared in the middle.
Because that's why I started doing a presentation plus one of the classes we use for taking
X squared. To the left of it, I put 1x, the long x. To the left, yes, just one. That's x. And to the right, I had 2 x's. To the right of the x squared, 2 x's. To the right.
And then
Leave that one, leave one.
To the right.
X. Yeah, and to the right, two of them, 2 long ones. And to the top of it, 2 long ones as well. And then next to these 2 long ones to the left, 2 unit ones to the left at the top.
so she ended up with 2 extra ones ending up with the same length.
And to the right, you missing the unit ones.
But the students will do it.
Right, so you end up with x plus 3 at the top here, or at the bottom, and x plus 3 on the side as well. So that's x plus 3 squared. So the missing number would have been 9.
So, yes.
It would be x squared plus 6x plus 9.
Okay, how did you get a 9? How did you come?
By counting the unit. By counting the units.
All right, so how many, yes, so after you use what you have, you're going to figure out how many of the units you need to make it a complete square, a perfect square, okay? Very good. Okay. So the answer here should be 9, and there should be 3. All right?
I'm sure how we do it.
Yeah, sure. All right, show them the method that you guys came up with. I guess that's it for them.
Not really confused.
Yeah, wait. Diana, are you saying something?
I mean, if you're using that method to do the binomial expansion after the continuation, that's a little scattered, not so?
It's a little.
If you have to use the method to the binomial expansion, and you draw like, so you have to multiply x times x squared to check back your answer. X times the 3 green plus 3x, and then x times, and then you have to say 3 times 3. Wouldn't be the 9 in the grouping, no?
Okay, so let me see if let me repeat it and you tell me if I'm understanding you properly. You're saying that the diagram, because the diagram is scattered like that, you would have to multiply to get your answer, to get the, that's what you're saying?
Let's say you want to verify or to use it to do binomial expansion, right? Where you have to say x times x is x squared, and x times the 3 green ones will be 3x. Then if it's scattered like that, how do you process from there?
If you're doing binomial expansion. Okay, so I'm not sure if I'm understanding what you're asking me, because
I think I can explain what she wants.
Yes.
If you look, Diane, if you look to the left, you see 1x, right? 1 long x. If you look to the bottom, you actually see 1. So if you want them to expand, remember it's x plus 3 times x plus 3. So it would become you tell them, okay, you multiplying out your bracket, so you can say x times x.
Oh, that's what you're saying.
You understand, Diane?
So you're saying if you weren't completing the squares, but you were given x squared, 1, 2, 3, 4, 6x, and 9, and you're doing the binomial expansion. That's what you're saying, Diane? Diane?
If you have to go the other direction, would you represent it like that? Sure.
I think she's saying if you start out with the x plus 3 and the x plus 3 and you want to multiply to get the answer in the middle.
Okay, so if I'm multiplying x plus 3, oh, but I will just later, but that's a different thing. Oh, I see what you're saying. That's a different concept. So I would start with x plus 3, and x plus 3. So all I would do is lay out. So I have my, so that's different. It wouldn't be able to, that's what it is. Finally understand what you're saying to me.
Okay, all right.
This would make it a little bit more challenging. But if you're having like this, they will say they need to put the x
and 3 there.
Yeah, so they have to fill out the middle. They have to fill out the middle into a square. So it's easier for them to see it. Not that it's impossible because some students are very specially aware and probably might see better than us. But it is better to be done this way. I see your point. It might be a better. That's what you're saying, Diane?
Yes, but if you have to transition to other things, it's a little rough, you know. I don't know. I really don't know how to transition this. As it is, you know. You understand? There's a continuation of thought, and it's just all over the place. Anyway, but it's good, eh? But people like me can't see that.
Some of the students are very spatially aware, so they probably, trust me, even especially the boys who learn to climb trees and go outside and put things together, they are very spatial, very, very spatial. Girls, we learn to stay in and wash, cook, and clean. We're not as so spatial as the boys who actually put things apart and put them back together. So they'll see things faster than us, probably. No, some boys are very, very spatial. And that's one of my weakest things, spatial awareness. I'm very weak. Yeah, very, very weak. Even driving, I'm trying, I drive a very electric car and I'm trying to figure out, can I take the space? I'm still doing left, right. So just to show you that I'm still like, is it left? But men tend to be a little, my husband would say, okay, turn left, turn right. I'm like, really? Yes. So guys are a little bit different, but is that the 7 already? All right, I'll just give you one more to try while we wrap up the class. Okay, and what's it get? 4? Okay. This is not it?
No, 7.
Okay, this one. All right, so what do I say? All right, the thing is this now. For this course, you will definitely have a test. The test is 40%. I'll send out your course outline and your assignment sheets. You have a presentation. Please pay attention in the class because on the test, some of these very things will be coming back. I won't give you anything that you haven't done. So, this class will fly by very quickly, and I don't know how much will get covered because you have a presentation to do, plus you have to do the test, and that is part of the class time. So we'll see what happens. But I'll definitely send out the course outline and the test and some of the things that you need to add to your kit, your math kit. You might need to add some things to your math kit, okay? I'll send out for sure elastic bands. You're gonna need paper plates. You're gonna need thumbtacks. I'm gonna use a paper plate for circle theorem. So
You're gonna write in the essays.
Hello.
Okay, so but Miss McCarthy, McCarthy, for the exam will be if it be done at home. The test, sorry. Do we need to go to will we have to go to site or will we staying at home to do the test?
I don't know. I need to speak to.
We'll have to go to site.
I think I need to speak to the coordinators. I think that would be more likely to go to the site so that you have invigilators and all of that.
And the presentations, is it group or single?
Okay, so the presentation is supposed to be peer presentation, but I need to look at it a little bit more. So I have it sorted out, but I have it for peer. So let me look at it one more time before I send it off, okay?
All right, no problem, thanks.
You don't want to work in pairs?
No, she just.
Okay. So I'll send it to. It's just for, and the presentation is basically to look at the topic on the CSEC thing. Look at the CSEC report and look at. So basically, that's what we're doing. So just for you to refine it. Yeah. So yeah, we're moving the hard part because we're actually doing the things. All right. That's the easy part. What we're doing is the easy part. It says you have some. You have like some come up and or you will address the. So what you will do, your presentation is based on the errors and misconceptions that is in the on the CSEC report. Then you have to probably come up with strategies to.
I mean, no 5-page report. Extra than 10 pages.
Yeah, and I don't want them long something. Anyhow, so basically what I'm asking you to do, and I'm sure that the log takes they want to go home. So what I'm going to you'll see it later. But basically what you need to do is to figure out how to address the problem. That's what you have to write up individually. So, but we'll ask it out later. We'll talk a little bit more. Sabina, are you okay? Caroline, are you there?
Okay, I was getting disconnected, but I'll just watch the video.
All right, bye. See you on Thursday, 2 o'clock.
All right, bye-bye.
Wait to see you.
Bye. Thanks. August Monday.
Bye.
Where are we going to be?
Thursday, the 6th of August.
We're not class 6.
So we're going to have to pick another day.
We're scheduled for that day? No, we're not.
The Tuesday, Thursday. They send out something right now? They send out something right now?
Bye. This does not do anything. If it affects you, I'll send a WhatsApp message. Bye. Bye, guys.
Check on that.
Well, you're a person working it. Yeah, but I don't want to die.
Stop recording.
Please, you
Oh, yeah.
Oh, thank you. So
I'm going to come back.